Hello. Do we have our dear colleague from Akamai here? Okay.
Hello,
Hello.
good morning.
Good morning.
I was trying to share my screen. It says all slots are
Okay.
taken.
Let's see.
Oh, I see now.
Is about to be shared. Yes, we see you now.
Great.
Okay, we can start if you're ready.
All right. Thanks, guys. Good morning. Hope you had your coffee, and guess I'm the only Indian speaker all the way from the other part of the globe. So today we'll talk a little bit about web performance and um, any questions or anything, just probably put in the Q&A panel. I'll take a peek every now and then and try to answer as much questions I can. Um, so a little bit about me. Sankalp, working as an architect in Akamai. So I also, whenever I'm not doing, tech stuff, I'm busy dabbling with stocks. So I've worked on technologies like web performance, analytics, and cybersecurity enterprise. And I come with a background of, networking, telecom, 4G, 5G, and that as well. Um, that was a bit about me. So what are we doing in this session, right? So we'll look at the role of content delivery networks in internet in a bird's eye view, and then we'll take this up a notch. When I say up a notch, I'm referring to the layer 7, the application layer, right? So we had some wonderful sessions yesterday, and I've seen the slides for today as well. So we are discussing about layer 3, layer 2, and even the physical layer on to some extent. So in this session, we will talk only on layer 7, the application layer, and we will expand on the concept of web performance or the web speed and what are the some important facts around it. And I'll also share some of my experience. I've worked with 300 400 companies in my tenure, so I'll share some of my experiences which probably might be helpful for the larger audience. And I'm trying to condense, usually this is an ocean, probably a 7-day workshop or something like that, so I'm condensing that information as much as I can. So if something's not clear, please use the Q&A panel. So first things first, what do content delivery networks do, right? And I'm sure many of the audience are already familiar with it, but for the benefit of larger audience, let's revisit it, right? As the name itself says, content delivery networks help in delivering the content to the end user. Now, what do I mean by helping, right? So there are three aspects we can look or examine CDN, right? One is availability, which was one of the primary reasons why CDN concept was conceived back probably 2.5 or 2 decades ago. um, some site goes down. A data center cannot handle that much amount of requests, right? There's a surge in traffic. Say, for example, there's some sales going on, right? Surge traffic, as we call it, right? So we want to avoid that because we can live with all the riders, but if the site itself is not up, then we have a problem, right? So availability is where the CDNs help. And the second and the most important one, or the primary reason why CDN came into existence, is performance. What do I mean by performance? Speed, right? So we had some talk about DevOps yesterday, um, and we talk about websites and everything. So what is the most important thing about internet, which is the speed, right? So we want things to load at a faster rate, right? So that's what performance is all about, and CDNs have ways to accelerate the site or the traffic delivery. And the latest entry to this, it was only availability and performance for a while, but then came the latest entry, which is security, right? Security is now becoming the single most important reason why companies are opting for CDNs. Why? Because two reasons. One is you want to catch the attacks as early as possible. When I say as early as possible, you have a website and somebody is trying to steal the credentials from it or some siphon off some attacks. You want to catch it at the page level itself, or you don't want to wait until that attack comes near your data center and inject some kind of malicious stuff in your data center, right? That's a recipe for disaster. So we want to catch them early, and that's where CDNs play an important role, because they are the front end army of servers which will catch the attacks even before they reach your actual data center. That's number one. And the second thing is you cannot protect against every day or every new attack that is out there. For example, classic example is the log4j attack, which created quite a lot of mess in, I think, in late December last year. It was mayhem. It was one of the worst kind, where even reputed government agencies were attacked, they were brought down, and at some point of time Akamai was seeing 2 million attack attempts per hour, and that's what Akamai mitigated. And I'm sure there are many other CDN companies, cloud companies. If you look at the cumulative, it's in the amount of billions. That much amount of attacks, volume of attacks, were stopped from reaching the data center. And that's, I'm talking about only one such attack. There can be uh, innumerous one. Every day you can see a lot of stuff. So security is turning out to be the biggest reason why companies are opting for, are taking the services of a CDN. But earlier it was, performance as well. But yeah, gradually we are transitioning. Now we'll expand on the performance aspect, not on the security one or the availability one as well, but we'll expand on the performance one. So how does a content delivery network improve performance? When the idea of a CDN was conceived, the first important or the big feature that was brought was caching, right? So there may be 40 members in the hall right now. Say all of you are visiting, say, facebook.com. Now there are certain elements on that page. Now a web page, when I started working, I thought that, when you hit a request on browser, it's just one request that goes out, fetches everything, and then it comes back, right? But that's not the case. So typically a web page is consists of 170, 150, or 400, 500 objects, which are brought by the browser and stitched together to form a visually appealing web page, right? Now there are certain elements of that page which can be shared amongst the user. For example, there are 42 members in the hall right now. All of them are accessing a particular site. Now there's no need to hit the origin with for the same request. For example, the RIPE logo, the RIPE NCC logo. We need not poll the data center saying that 42 folks need not go there and ask for the same logo, right? We can store it somewhere mid and we can share it amongst the users. Of course, this is not sensitive data. We can do that, and probably we can go to the origin or the data center only for this sensitive content, right? So that's what caching is, right? Temporary storage of objects and then serving it as close to the user as possible. That will save some time and also some bandwidth, and even network operators benefit as well, because they don't have to handle unnecessary traffic, right? So that has been the single biggest advantage when we talk about performance. And then there are other features as well. Route optimization, say, um, from India to for the request to travel to Atlanta, there might be n number of ways where we can do that, right? But of course, the traditional BGP or whatever is not the best way. There can be better alternate ways, and that's where CDNs come in with their large amount of peering, and they can continuously gauge which all alternate paths that they can take, and probably take a better path, right? That's what we call route optimization, and that plays a critical role when we have cable cuts or submarine cuts, right? Submarine cable cuts, right? So the convergence or the fallback time with a CDN in place is much more less. And then there are optimizations done at the DNS level, maybe at the TCP level. We can meddle around with the congestion windows, probably keep it aggressive, and even on the SSL handshake front. All this constitute to your or contribute to your overall page load time, or the web page or the API load times, right? So we need to fine tune at every level. And last but not the least, but probably the most important, the HTTP protocol upon which the internet operates, or the application layer operates, itself offers some, what do they say, some room for optimization, right? Say, for example, you're browsing a website, and you know for a fact that um, uh, there's a certain image that the browser will need it anyway, or certain file that the browser will require anyway, and eventually it will make a request. So there is room in the HTTP protocol for proactively pushing it, right? Pushing it. Don't wait for the browser to make a request. You push it proactively. So that way, the end user will feel that, hey, this website is performing good, right? It's speed, right? So there are lots of optimizations on the protocol itself, say compression, image compression, and text compression, or pushing it, or keeping stuff ready. So all these are done by CDNs as well, to contribute to the speed of the site, or to improve the speed of the site. Now comes the question, does it really matter? Right? What's the point if my site loads in 3 seconds or 4 seconds? How does it matter? I mean, I would understand if it loads in 15 seconds. That's not acceptable. But what about 3 to 4? Does it make any difference? Or 2 to 3? Right? So I want to propose two facts, which will give us an idea. The first fact. So when we look at the data of the last 10 years, so HTTP Archive is a project which is run where we look at the internet traffic. And when we look at the data of the last 10 years, it tells us one thing. The median page size of a desktop size, of a typical desktop size, has increased by 3 times. And the mobile side, it's even big. It has increased 7 times in the last 10 years alone. And mind you, when I say 10 years, it does seem like, it's in the distant future, but it's not. It's 2012, right? It's just right around the corner, right? So what was, say, 500 KB site in 2012 is essentially 3.5 MB right now, right? And this is going to grow because we are in the metaverse world now. We are looking for videos on the site and everything. So this is going to grow. So the page size will always keep increasing. And the other fact that I want to propose is a research study which was conducted by Akamai way back in 2017. Now, don't say that, hey, Sankalp, 2017 study, didn't you have a latest one? I have a reason to come with the 5-year-old study, and I'll come to that in a moment. So Akamai did a study in 2017 on e-commerce, and they said 3 things. The first thing is 100 millisecond delay in a website load time can hurt conversion rates by 7%. Now, what is a conversion rate? Conversion rate is nothing but a user goes on to a web page and he makes a purchase. So we call them a converted user, right? So we are getting revenue from that user, end user. So we call that as a conversion. So just 100 millisecond delay can hurt the conversion rates by 7%. And that's massive, right? And if you think that's massive, let's look at the second fact. It says 2-second delay in web page load time can increase bounce rates by 103%. That's big. What is a bounce rate? It means a user who didn't make a purchase. I mean, he went on a site, he saw it was slow and he just bounced off it, right? He didn't make a purchase. So a 2-second delay can impact your revenue in a big manner. And the third fact is 53% of the mobile site visitors tend to leave the page when the page takes more than 3 seconds to load. All right. So these are three important facts which reinforce the importance of speed or web performance. And the reason I'm bringing 2017 factors, um, I have the latest stats, and it's even more um, um, it's even more worse. Why? Because it's COVID, right? I looked at the stats, and any way you look at it, be it retail, be it pharma, be it tech, be it engineering, be it IT, the usage of internet has exploded 50%, 60%, 70% increase than pre-COVID era, right? So this is going to grow because that's a new normal, right? And it's not only this study, there are umpteen number of studies available. There was one on my Amazon which says probably 100 millisecond delay impacted their revenue by 1%, and 1% revenue of Amazon is huge. That's almost $1 billion, right? And Walmart did a similar study, Netflix did a study, and all of them come to the same conclusion that in the web performance world, every 1 millisecond or every 100 milliseconds or every 10 milliseconds mean mega dollars, right? And of course, I'm pointing it back to the metaverse. This is gonna grow big, right? Now, what do you do when someone claims their website is slow, right? And that's why I'm here for, right? I've done performance debugging for 200, 300 companies across the globe, starting from APAC, EMEA, Asia, Southeast Asia, all regions. So I'm here to share some of my experiences. And I want to start off with a quote. And this is a story which I read back in school about a doctor who was born blind but went on to graduate in medicine and had a stellar career in medicine. So Dr. David Hartman, um, and he did some outstanding stuff in the field of medicine in the late 1970s. So when people were shocked, I mean, people were shocked, how can a blind person accomplish such stuff? And they asked the professor, and what was his secret? Like, is it cheating or something? So his professor said uh, something very appealing, which is, if given the chance to talk about themselves, patients are often very good judges on what's wrong with them. And I want to extend that with the web performance itself. So whenever I hear a company or a client or a customer who comes to me and says, my site is having bad performance, I want to hear more, right? Because that will tell me what performance means to them, how are they measuring, what are they looking for, because this is a broad concept, right? So the first step that I would probably share is hear the customer. Now, let me break down my approach in handling the performance problem. The first thing is I want to hear what is their idea of performance. For some customers or some companies, it may be like, say for example, American Airlines. I was working with American Airlines, and they said that the website performance needs to be fine-tuned. And when I asked them what were they looking for, the CTO showed me the search bar. The search bar, they said that in the airline industry, what matters to us is the time it takes for the search results to come up, right? That's what's important for them. For an e-commerce, it's something different. For a garment site, it's different. From pharmacy site, it's different. So there's different ways of looking performance, and we need to figure that piece out. And the second thing is, how are they measuring, right? Are they using some tools? And I know there's this next talk on Wi-Fi monitoring, if I'm right, and which expands on Wi-Fi speed monitoring and all that. So there are many tools available. So what are they using it? And I'm going to talk about this in the next slide, which location. And that's important because if a person, and I had this experience, so there was this one jeweler, a jeweler company who came to me and said, Sankalp, our web performance is very bad. And when I asked them more, it turned out that there was this one tiny location in somewhere interior Brazil, and I figured out that data point. I extracted the data point. It was somewhere in interior Brazil where they had no market. Nobody was using that particular site there, and the connection was 2G. So obviously you would see a bloated up size, right? So bloated time, by the way. So location is very important. Where are they measuring? And also, what are the scales that we should use, right? Scales, how do we measure it? Do we measure it in terms of bandwidth, page load times, throughput? What should we exactly measure, right? And also, what scale should we use? Should we use the average? And I'm going to expand on each of these three aspects: the tool, the metric, and the scale, right? And then we go on to build or debug the web performance, right? So what we are doing in the initial steps is to create some context. And I feel whenever I'm doing a web performance analysis, I make it a point to build this context. And it's very, very important, because without context, you cannot give an answer or debug and say this is the reason. Because my page loads at 7 seconds, but what was the connection quality? Is it in a particular network? Is it in a particular ASN? We need to collect all that context in order to make informed decisions. Think of it like an art, right? So we can have the machine Mona Lisa, machine printed one, or the actual Mona Lisa. Now it looks exactly the same, but what's the difference? The difference is the context. Context adds value to your debugging. Now, what are the ways people measure web performance today? And you would be surprised. The first one is stop clock. They just look at their clock and say that my page loads at 4 seconds, 3 seconds, right? I mean, you might think it's funny, but it actually happens. Some of the biggest companies do that. There was this one company which I was working with, image optimization techniques, and they came to me and said that, Sankalp, it's not working out. I'm like, okay, what went wrong? And they said, we distributed it to 20 employees and they didn't like it. And I said, what didn't they like it? And they were like, no, they just felt it was not fast enough. Like, these are subjective terms and people do use them, right? So, and also layer 3 pings, TCP pings to the data center, and that sort of they come to me and tell that performance is bad. Of course, it's a different layer altogether, so we shouldn't be relying on layer 3 data. In the second, lot of companies go for some free available tools like web page test, page speed insights. Those are the popular ones. There's GTmetrix, Uptrends as well. You just put in a URL and it will give you all the information. And then there are some who use real probes which are available. Catchpoint, Ripe Atlas is one good option. Rigor, Dynatrace, these are probes hosted in certain parts of the world, and we can poll the website or conduct some tests, and based on that we can make an inference on what's going on with the site. And then there are my favorite, which is the RUM solution. RUM solution is the real user data. The 100% of your users the data can be collated and can be examined. So I got a beep which says 8 minutes, so I'm just going to accelerate it. So if you don't have the data right now, how do you go about on debugging? The single, or if the site is reasonably popular, you will already find the data in the Chrome's user repository. Chrome has this user experience report. You can poll it and you can always get the performance data. But why is it not used these days? I never had a company come to me with a Crux report, but useful amount of information, but nobody refers it. And the reason I think is because of the difficulty in extracting it. You had to run some queries, which not all are tech savvy. So check this out, Crux report, and it really has good information. Quickly moving on. What is the how do we saw the tools? Now what is the scale should be measured, right? And usually companies tend to go for the traditional averages, but the problem with that is averages tend to dissipate the error within the whole data set. For example, I've given a sample data set. If you look at the last two values, it's 22-25 seconds, probably something wrong with the probe, but when you look at the average, it's misleading. It says 6.92 seconds, but that's not the case. It was only 2 data points that were screwed up, right? So the cardinal sin in web performance is to use averages. Usually we tend to use percentiles, which is arrange the data set in ascending order, take the middle value and call it the median or the 50th percentile. Now that does two important things. One, it will tell you what your 50% of the users experienced, and then it will also hint what your 50% of the users might experience, right? So the best starting point or the accepted norm is to use percentile. You can always start with the median percentile, fine tune it, and then move on to the higher one. Say, for example, 75th or 99. Of course, we'll be foraying into the error world or the long tail, as we call it. But yeah, the good starting point is always the median. Now, we talked about the scale, we talked about the tools. What about metrics? And as I said, metrics is traditionally we used to measure it in page load times. What is the time for a page to load? Like we look at all the number of HTTP requests, and once all of them loaded, we would say that, hey, the page loaded at 14-15 seconds. But the problem is it doesn't capture the user perception. Say there is one tiny logo, a Twitter logo on your site, which took for some reason 20 seconds, and you say that your page loaded in 20 seconds. That's not really doing justice, right? Because it's just one tiny plugin which didn't even matter, right? The rest of the page loaded fine. So the challenge is we have to measure the perception of the user, right? So, and there are metrics to do that. There is interactivity metrics, time to interactive. When did the page actually become interactive? When the actual user made the interaction, and all sorts of stuff. So each website we have to first analyze and then fix what is the metric suitable for this particular website. For example, if it's a gaming site, I would say time to interactivity, right? So you have a beautiful site, but the sign in button doesn't work, right? What's the use of the website, right? So interactivity matters the most there, right? So some of the metrics that I have jolted down, and I'm not going to explain all of those because of the time constraint, but I'll jump on to the next slide. Core Web Vitals. So Google, for some reason, was extremely secret about what metrics what it used, or what was the algorithm that it employed to for their search result rankings, and that whenever there's secrecy, there's always this reverse engineering and speculation, and there were some wild theories out there because of that. So back in 2020, Google came out honestly and said that, hey guys, don't worry about all those metrics. We'll give you 3 ones and you stick to that, and that will help your site in the search results and everywhere, right? So the first one is largest contentful paint, which focuses on the loading, right? For example, whatever the visible viewport on your screen, what is the largest element on that screen, right? And how much time it took to load that. So Google said this is important because if it's the largest object in your page, then of course the user gets a perception if it loads faster that the site itself is faster, right? So it's important to measure that. And the second is first input delay, which is what is the time the web page took to interact or to respond, right? So that's FID. And then they bought an interesting one, which is cumulative layout shift, which was not there before, but this was very interesting. So have you experienced in a site, you go and then suddenly you type in your credentials and then the login button shifts somewhere else, right? The layout keeps on shifting because of bad coding, right? So that's what they want to measure. They want the shift to be as minimal as possible, right? So they said that you focus on these three metrics, the other are implicit, right? So of course, it's a large topic, but we can reserve it for some other day. I wanted to do a demo of this one particular famous Indian e-commerce site, bigbasket.com, but of course the presentation doesn't support video, but I just took a snapshot as well. If you look at it, some of the things I've highlighted, it's an Indian grocery website, famous one. The carousel images keeps on changing when you open that site. So the layout keeps on shifting, right? And there's a surprise pop-up which comes in and says, hey, give me your zip code. Right, so that also impacts the user experience, and the button keeps on changing, right? You can see this in any website for that matter, which is of course not so well fine-tuned, right? I wanted to talk about this one little metric, and as an optional one, TTFB, which was for years and years, it was considered as the biggest holy grail metric, and the whole argument is flawed. TTFB is like the time it took to load one HTML, or to receive the first byte of the HTML, which is nowhere near the equivalent of the whole web, the speed itself. So I'm not going to go in deep on that because of time constraint. I'm nearly running out of time. So anyway, for any discussions around internet, I know I got a few pings on if I can share, if we can extend on this topic, do feel free to connect with me on LinkedIn. That's the only place where I'm active. But yeah, that's it I had for the day. I don't know if we have time for Q&A, but yeah, thank you very much.
Thank you. Let's see if we can squeeze in a question or two. If there are one. I don't see anybody in the queue. Fortunately, there are no questions.
Great. That means I did a good job at presenting.
Well, most likely. Okay. Thank you, Sankalp.
All right. Thank you. Thank you, guys.
Can move forward. It's also remote, yes. Okay. So this is Wi-Fi network monitoring with GÉANT WiFiMon by Nikos Kostopoulos. Is Nikos there? Okay. Excellent.
Hello, can you hear me?
I leave forward to you, Nikos.
Sorry. Can you hear me? Can you verify that?
Yes, we can.
Okay, thank you.
You just have to share the slides. Okay.
Okay, you're
your slides now.
Thank you. Then I'm ready to start, right? Okay, hello everyone. My name is Nikos Kostopoulos, and I will present to you WiFiMon, which is a service offered by GÉANT, the Pan-European backbone network. First, I will start with the introduction of WiFiMon. What is WiFiMon? WiFiMon is a tool that monitors Wi-Fi network performance as experienced by end users. To do that, it combines two kinds of measurements: crowdsourced measurements from end users and hardware probe measurements from devices located at fixed points within the network. Moreover, a WiFiMon can monitor any Wi-Fi network. However, in IEEE 802.1x networks, for example, such as EDROM, you can provide richer analysis options. For example, you can leverage on information from radius and DHCP logs to provide throughput information per access point within the network. So the contribution of WiFiMon is that it aims to detect Wi-Fi throughput degradation and determine underperforming areas within a Wi-Fi network. The reason that the aim of WiFiMon is to inform admins that they need to enhance the performance of the Wi-Fi networks, for example, by installing more access points. Now we compare what differentiates WiFiMon and other monitoring solutions. WiFiMon monitors the end user experience. It monitors from the end user perspective, how the user experiences the Wi-Fi performance in the network. And a very important aspect of WiFiMon is that you do not need to install any app or for the user to intervene. For example, the user is not required to press a button to trigger a measurement. Measurements are triggered automatically. And finally, there is a centralized view of Wi-Fi performance available to the Wi-Fi administrator. Instead of informing the end user, such as popular tools that I will show later, the information about the Wi-Fi performance is delivered to the WiFiMon administrator. I have included a comparison with a very popular O-class speed test. In WiFiMon, in order to trigger a measurement, you do not have to press a button like Go in O-class speed test, but you just visit the website that you have enabled with WiFiMon technology, and measurements are triggered automatically. And finally, results are collected by the WiFiMon administrator, whereas in O-class speed test, you know very well that the one that is informed about the performance results is the end user, and not the Wi-Fi administrator, sorry. Now we'll go deeper into the design features and operation of WiFiMon. The main design features of WiFiMon are the following. It monitors using two kinds of measurements, crowdsourced and hardware probe measurements. Recall that crowdsourced measurements are retrieved from end users, for example, laptops, mobile devices, and hardware probes are, in the case of WiFiMon, Raspberry Pi devices, but you could use any device that is useful. Moreover, we correlate with radius and DHCP logs to provide analysis per access point, and we always respect end user privacy because all this sensitive information, including MAC addresses and IP addresses of end users, are stored hashed in our databases. Then, WiFiMon is independent of Wi-Fi technology. It can monitor, and hardware vendor, it can monitor any Wi-Fi network, but it provides stronger results in IEEE 802.1x networks, such as SD-WAN. And finally, WiFiMon performs lightweight, active monitoring without impact on end user browsing experience. This is in the following figure, we depict the basics of the WiFiMon operation. Note that there are two kinds of data sources in WiFiMon. The first one is the WiFiMon performance data sources, and the other one is the accounting data sources. The performance data sources include two kinds of probes, the software probes, this is how we term the end users, and the hardware probes. In our case, recall that we use Raspberry Pi devices. The second data source are the logs exported from radius and DHCP servers using file bit agents. This information is delivered to the WiFiMon analysis server, that is the central processing and the central processing component of WiFiMon. It provides correlation with logs and visualization options towards the WiFiMon administrator. So, in order to perform the measurements, the first thing that the WiFiMon administrator has to do is to edit a tab that includes the monitor subnets. The reason that we specify the monitor subnets is in order to specify what exactly we want to measure, in order to leave out some wired segments or other wireless segments. For example, this WiFiMon enabled website, you could visit it from another network that we do not want to monitor. So after doing that, the software or hardware probes visit a monitored website, the website that we have enabled with WiFiMon technology, and they fetch the HTML code of that page. Automatically, they trigger some performance test measurements against a simple component of WiFiMon, the WiFiMon test server. To perform this, to calculate these performance metrics, the probes, the software and hardware probes, download some garbage data, test images or test data in general, and they calculate the performance metrics, which may be download, upload, throughput, or the HTTP ping router time, and they stream it to the WiFiMon analysis server for processing and correlation with the available logs. Now we'll go deeper into the components of WiFiMon. The first one that we'll analyze is the WiFiMon test server, and the purpose of this component is to hold the code and test data for the performance measurements performed by both software probes and hardware probes. And it is a component that is based on JavaScript technology in order to automatically trigger these measurements. The only thing that a WiFiMon administrator has to do is to insert some HTML script tags pointing to the test flows of the WiFiMon server to a frequently visited website. For example, for the conference venue that we are right now, we could insert these HTML lines in the agenda. Or for a campus network, we could insert the necessary HTML lines in the university main website. And in WiFiMon, we perform measurements of the HTTP service that constitutes the majority of internet traffic. WiFiMon is based on 3 available test tools. NetTest, which is a rather old test tool, but we have left it there for legacy purposes, and the more modern ones, Akamai Boomerang and LibreSpeed Speed Test. Where for these tools, you can find more information in the links that I have included in my presentation. A very important detail about the WiFiMon test server is where to place it. The test server has to be placed close to the monitor networks. And this is because the round-trip time between end devices and the test server is included in the results. However, even if this is not possible, WiFiMon will still provide useful information by capturing the relative changes in Wi-Fi performance. So in WiFiMon, we're not particularly interested in reporting the specific number of the download throughput, but mainly capturing the relative changes where throughput degrades or where throughput is higher. Going on, I will speak about the software probes. Recall that these probes are the end-user devices, for example, laptops, smartphones, or any Wi-Fi-enabled device belonging to an end-user. And the crowdsourced measurements are triggered against the WiFiMon server when we visit the WiFi-enabled site, the site containing the HTML lines. And the important detail here is that these measurements are not triggered by users themselves, but they are triggered automatically when we enter this site. So there is no requirement to install additional software in end-user devices like other popular Wi-Fi performance measurement tools. And we have minor details that we have included a cookie value that is used to regulate repetitive measurements. For example, if this cookie value is specified to be 1 minute, you cannot repeat the measurement from a specific IP address. And this is used in order not to overload the components of WiFiMon. And in the following example, I have included the necessary script tags that you have to include in order to enable a site with the Akamai Boomerang testing. The hardware probes are devices that perform performance measurements from fixed points within the network, and therefore the distance between the probes and the access points remains relatively constant. And the purpose of these components is to provide a baseline throughput complementing the crowdsourced measurements. Of course, even if you are not interested in crowdsourced measurements and you don't want to include them in your measurements, you can still use the probes as standalone devices, and they will report very useful results. And the performance measurements are very similar to the software probes. They are performed in the same manner, but based on cron tabs that trigger the measurements in predefined intervals. However, apart from these measurements, we also have included additional data from the probes about the monitor SSID and the nearby SSIDs. And these are the access point, signal strength, link quality, bit rate, and transmission power. And in WiFiMon, we have tested this technology on Raspberry Pi devices, specifically version 3 and version 4, but any single board computer would be possible to deliver these measurements. And finally, we have the WiFiMon analysis server. I wouldn't like to stick much to this slide because I have already described you these details. The analysis server includes 2 components: the agent that collects and processes the received monitoring data, and a user interface that provides visualizations through a Kibana interface to the WiFiMon administrator. So you can see that in this picture, the analysis server accepts counted data, meaning radius and TCP logs, and performance measurements, processes them, and correlates them. All the information is stored within an Elasticsearch cluster. And this is a picture from the WiFiMon user interface. This particular tab includes information delivered from the hardware probes. Specifically, you have 3 hardware probes here. On the left, you can see performance results delivered from 3 different probes. And on the right, you can see that all these lines on the left have been aggregated by calculating their average to provide a more clear line to visualize the performance within the network. Of course, in WiFiMon include much more measurements, much more results. We provide dashboards available for average values, median values, maximum, minimum, and 95th percentile values. And the sources of these dashboards are both crowdsourced and hardware probe measurements. And when we say performance measurements, we mean download throughput, upload throughput, and HTTP ping route trip time. And notably, these results may be uncorrelated or correlated with available access points if we use information available from radius and DHCP logs. Now I'll provide more information about the correlation with radius and DHCP logs. Logs are extracted from the corresponding servers using a file bit instance, and they are processed and transformed in the Wi-Fi analysis server by logstacks. After that, the transformed information is stored in the Elasticsearch cluster of the Wi-Fi analysis server, and we provide two correlation options. The first correlation option is with the end user IP address that relies only on the radius logs. This particularly relies on a field called the frame IP address. It's included in IEEE 802.1x networks. However, this field is not always present. And because of that, we have included a second option that also uses the end user. It correlates performance measurements with the end user MAC address. And in this case, we have to rely both on radius and DHCP logs. A very important detail here is that sensitive information, such as IP and MAC addresses, are always secured and transient using a TLS encrypted channel, and they are always stored in our databases or Elasticsearch cluster HAST. And this is done based on the plugin offered by ElkStack, XPack. And finally, some other features of WiFiMon is that it provides notification of version updates. For example, you can press a button and learn about a new version of WiFiMon if you have to update or not. And this enables us to also monitor the Wi-Fi utilization, which is an optional feature, where we are able to know how many users are using WiFiMon. We have included a log exporter that is specifically designed for a drone. It is a JSON exporter that also an optional feature that can stream hardware probe data towards a collector of the EDROM project. But this exporter can be used with any JSON collector that you want. And finally, we have enabled recently the Wi-Fi administrators to use multiple Wi-Fi test server instances and deliver different results from various areas within their networks. Now we'll speak about the installation of WiFiMon. You can install WiFiMon installation is fully automated. We have recently abandoned any manual installation of WiFiMon, and you can do that in two ways. The first option, and most preferred, is to install all components within the premises of the organization. And the most difficult component is the Wi-Fi analysis server, whose installation is done automatically using an Ansible playbook. The Wi-Fi test server is still installed manually, but the installation is extremely easy. And in this case, all data stay within the institution premises. Moreover, we have included the second option. The second option is to use a platform that is called NMAS. This is another GÉANT service. And NMAS is a platform that offers Dockerized services. You can, for example, ask for an account in NMAS and deploy Docker containers of WiFiMon. However, this solution is more appropriate for testing or trying WiFiMon. The solution of Ansible Playbook takes around 15 minutes to complete the installation, and the solution of NMAS takes about 10 minutes. Some more details about the installation of the analysis server using Ansible. The minimum specifications are the most important. We require 4 CPU cores, 8 GB of RAM, and not enough free disk space. We have tested multiple operating systems, and the main thing that the interested user has to do is to edit the variables of the Ansible playbook to to include his email or change the appropriate passwords. Now I'd like to tell you more about to include experience from recent WiFiMon pilots. We have recently performed 2 WiFiMon pilots in conference venues. The first one was in TNC19 conference in Tallinn. This is the most, let's say, popular conference in GÉANT. And the second one was in GÉANT Symposium 2020 in Ljubljana, at that particular venue that you are right now. I will not go into deeper details about TNC19, but I have included it in my presentation for you to see it. However, I will describe more about the GÉANT Symposium pilot. We monitored around 250 participants, and we specifically monitored the Ethereum SSID. We included both probe measurements, both hardware probe and software probe measurements. For hardware probes, we used 7 Raspberry Pi devices that triggered performance measurements in 5-minute intervals. And concerning the software probes, we inserted the HTML lines in the conference agenda, after, of course, receiving consent during the online registration process of the participants. And the test server was located in Arnes, so very close to the venue. I will skip these slides. You can see them in my presentation. And I will go to the GÉANT Symposium. This figure depicts the average download throughput reported by crowdsourced measurements during the first day of the symposium. And you can see that in the time intervals marked with the number 1, we can see some very interesting major drops. And these were periods, after analyzing these time intervals, we saw that these were periods that followed the coffee break. And we assumed that more people were visiting the symposium agenda, and they overloaded the access points of the venue. At the time interval marked with the number 2, we can see a notable drop. And we saw that this was during and after lunch time, when most participants gathered in the space, and we presumed that they overloaded specific access points within the venue. And we can see that there are also higher levels of reported download throughput. And this was probably when participants were distributed across many different stations, so they didn't overload. The load was shared across the different access points of the venue. Another very interesting figure is that is the one reporting the average download throughput by 2 of our hardware probes. You can see that looking at that figure, we can see that both hardware probes follow similar trends, and both hardware probes consisted drops reported by the software probe measurements in the previous slide. One minor detail here is that a lot of people ask us why the average download throughput reported by the probes is less than the one reported by crowdsourced measurements. This is because as they are located in fixed points within the network, we would expect that they would deliver better performance. However, this is because we placed the available probes near the power plugs that were far away from the access points of that were further from access points than the audience. For example, at floors, and they couldn't. So the laptops and mobile devices of the audience reported higher download throughput. I have also included in my presentation a table including metrics delivered from probes and their corresponding performance measurements. For example, in this table, you can see all the 7 hardware probes, their metrics, signal level, bitrate, link quality, and bit transmission power, and their performance measurements, download and upload throughput, and ping latency. An important observation here is that the metrics of the wireless network metrics do not necessarily follow those of performance measurements. For example, look at the first probe. The first probe reports the best average link quality, 67, but the performance results are among the worst compared to the other probes. Look also at the 5th hardware probe. It has the worst average link quality, but the performance results reported are among the best. So we concluded that we cannot be based only on the hardware probe measurements. We need multiple sources of information, including the crowdsourced measurements from end users. Some future steps of WiFiMon is that we want to include additional information from the probes, for example, processing, memory, the disk information, frequency of Wi-Fi. And one solution that we're currently working on is to integrate WiFiMon with the T-WAMP protocol to compare the measurements with performance with the throughput measurements. We would like to consider additional monitoring tools to accompany the ones that we have now, Akamai Boomerang and Speed Test, and we'd like to perform time series analysis to automatically predict and inform the Wi-Fi administrator of performance drops. Find a method to automatically correlate between crowdsource and probe measurements and provide support for IPv6. And in this slide, I have included some useful links. You can check out the promotional video of WiFiMon. You can see the Wi-Fi info share that it is a 1.5 hour presentation that includes more details about WiFiMon, previous presentations, or a research paper at a popular conference around wireless networking. So thank you.
Okay.
Thank you. Sorry, you can go.
Thank you, Nikos. I believe we have a question. Alexander? Fortunately, it seemed he went offline. Let's give him a minute. He reconnects. Okay. Fortunately, no. No, unfortunately, it didn't manage to connect properly. Okay, unfortunately, that's it, Nikos. Thank you for the presentation.
Thank you.
Okay, and the last one for today, Ondřej Caletka, the need to transition to IPv6. This would be a local presentation.
Share my slides. Yes, perfect. Okay, we have slides. Does it switch? Yes. Can you hear me? Yes, perfect. Hello, good morning. My name is Ondřej Caletka. I work for Ripen CC. And in this talk, I'm going to present something that I call yet another motivational talk, because some people, including me, think that we should really keep convincing people that there is a reason why IPv6 should be deployed. Yeah. So first of all, aren't we there yet? We've been talking, or IPv6 has been like deployed, and we've been talking about it at least since 2012, which was 10 years ago, when we have this World IPv6 launch, where like the amount of IPv6 content grew rapidly. And since then, the stats are still growing. The most optimistic, let's say, is this graph from Google, which basically doubles every maybe 5 years. This is like 5 years on the graph, and it jumped from something like 15-ish% to something like 30-ish. Yeah, there's regarding operating system support, this is really not an issue. We already exchanged all our devices to those that are IPv6 ready, so there shouldn't be an issue. But at the same time, if you look, you see that the majority still uses IPv4 only. And unfortunately, IPv6 is a second-class citizen. It often happens that IPv4 is like resolved immediately, but when an IPv6 is only resolved in a free capacity, and of course everybody is lacking free capacity, so sometimes it's like resolved like never. Uh, and we cannot, unfortunately, talk about motivation for IPv6 without talking about IPv4. So let's see how the situation with IPv4 is. And regarding RIPE and CC service region, it's indeed not very good. It started back in 2012, which is again like 10 years, almost 10 years, where we opened this depletion phase and we started allocating only a limited amount of IPv4 resources in order to save some of these precious IPv4 addresses for the future. And this future ended in 2019, where we reached the 0 and opened this waiting list, which first like opened for only for a while and got empty for quite a long time. But then at the end of last year, there was this something what I call the second wave of waiting list. And as you see now, the numbers are like outgoing the first wave of the waiting list quite a lot. And in case you would have this idea that you will just get some more IPv4 addresses by starting up an LIR, then you can see that there are some 700-ish people in front of you who did the same and are still waiting whether they will get some IPv4 resources. So you really have to resort for transfer market. Also, even if you wait the queue, you just get 256 addresses, so not that much. And transfer market, yeah, the prices are sort of like growing, even though now it's a little bit stagnating. And what we see is that, yeah, we are seeing this anti-pattern of centralization of everything, because those big players that made a lot of money on providing services before now can use that lot of money to buy more IPv4 addresses, either to provide more services in the future or maybe just to block anyone else from buying them. So so this is like the reality of what's happening, and it's indeed not really anything that we can say it's anything worth being part of it. So another thing that we should look at realistically, because of course in the beginning the internet has this idea of anybody being able to connect to anybody, and this idea was basically destroyed by lack of enough IP addresses. In case so the standard or the de facto situation today is that if you are a home user, you probably don't need a public address, a unique address, because GRNet is a thing that just is there and probably will be for long. And they are getting better and better. So even though there are more and more users, those more and more users somehow can be put into the same amount of public address space. But this doesn't work well for enterprises. They usually demand having their unique IP4 addresses. And in case you are someone like colocation provider or virtual server provider, then there's even like that every customer needs like several IP4 addresses, and usually like colocation service without IP address range is very hard to offer. The bad news here is that this doesn't get better until IPv6 is universally deployed. If only you deploy it, you will be still dependent on the rest of the world to do it as well, at least significant part of it. But the good news is that you can actually think about undeploying IP4 from all the places where it's not strictly necessary, like parts of your infrastructure. And in this way, you can save some precious addresses for more important purposes. So what advantage can you see now if you deploy IPv6 already? First of all, it's the only solution that allows some growth of services, because the amount of addresses will not be limit anymore. There will be other limits, but definitely not just number of addresses. Also, already right now, you can deploy IPv6 to make less strain on your carrier grade NAT equipment, as most prominent websites that are also like very content, let's say, significant in a way how many traffic they generate, are already available over IP dual stack, IPv4, IPv6. So if you offload the traffic to v6, the less sessions and the less traffic goes to carrier grade NAT, which means that probably you don't have to upgrade it as soon as you would have without v6. As we see more and more problems related to IP address sharing, so a typical thing is geolocation of reused address blocks that have been reassigned to somebody. If you buy addresses from some market, it can happen that there are many geolocation databases with wrong content. The same with blacklist or some rate limits regard to sharing addresses. This is all the operational issues that people are facing just because the addresses are scarce and they are shared maybe too much. Another thing that as an ISP usually face a problem of data retention, which most countries require you to somehow have a trace who used which IP address at which time, which is of course hard with carrier grade NAT because it requires per session loggings, which can be like lots of data logged. And this can be much simpler if you just go to IPv6 and deploy it statically, which is the preferred solution, of course, because there are enough addresses. And last thing, pretty important for enterprises, and this is something that enterprises are really struggling with, is that sooner or later enterprise will get merged or acquiesced by some other. And usually, because there's just limited number of private IPv4 ranges, they usually happen to be using the same private IPv4 ranges, even though they are now one company. And it gets to the situation where parts of one component cannot talk to each other because they use exactly the same IP4 addresses, and changing one or the other part is both very painful process. So this is something that can also be really nicely resolved by taking as much as IPv4 out of the system and using IPv6 as much as possible. Yeah, so in case I already convinced you that it's worth deploying IPv6, I would like to stress that it's necessary to do it in some future-proof way. That means that you don't just copy one-on-one what you have in v4 and change it to v6, but accommodate fact that some of the IPv4 deployments, or most of them, are actually compromises of what is possible due to the fact that the address space is limited, and in v6 we don't have such limits. So it should always start with a good addressing plan, possibly from scratch, grouping prefixes by functions, by location, by security policies. Don't let machines with different security policies share the same subnet, which is often the case in v4, where there are like exceptions for just a single IP for addresses out of a bigger subnets because of limits. And so do proper addressing plan, make this deployment as future-proof as possible. Of course, always it's necessary to deploy native v6, because if your v6 deployment is maybe simple thing like 6RD, where you use IPv4 as a barrier protocol for v6, then you rely on IPv4 forever. And if the plan is to turn off IPv4 at some point, this is not a good idea. What is a good idea is to have some transition mechanism to support IPv4 as long as it's necessary. The most basic transition mechanism is called dual stack, which means basically running both at the same time. But there are others, and they seem to be very more and more usable, because like big mobile carriers are using them very well. And every time when I talk about IPv6, somebody asks why this new protocol is so complicated. Why didn't they just extend IPv4 by a few more octets? And there are two answers to it. This, first of all, even a minimum extension of IPv4 means incompatibility. So even if you reused one extra bit in the IPv4 header to double the possible address space, this will create incompatibility that would require every single endpoint device to be upgraded to understand the new protocol. So if you need to upgrade every single endpoint, then why don't do also something else? And the other thing also that I really like to point out is that IPv6 also provides solutions to problems that never were solved in v4, because in v4 it was just not possible to have a bunch of public IP addresses in your home network. If you had IPv4 address public, it ends at the WAN interface of your home router, but never in your local network. And that's something that IPv6 can provide. And for that, of course, there have to be new protocols with new features, and unfortunately also new vulnerabilities or security aspects. So this is something that people are often scared, whether maybe that, or they say we don't deploy IPv6 because of security. It's necessary to say that there's nothing like more or less secure if we compare v4 and v6. Both protocols have their issues that can be mitigated somehow. Important thing is that global addressing does not imply that everything should be globally reachable. Firewalls still exist even in v6. So you don't. So just the fact that you are using globally unique address doesn't mean that anybody from the world can contact you on that address. What is true is that some protocols that support IPv6 are a bit different, and this difference also creates some new vulnerabilities. And what we really advise here is that security is never a product that you can buy. Security is always some process that is ongoing, and the best security feature you can have is knowledge. And speaking of knowledge, I would like to point out that BES Ripen CC just launched recently a new e-learning course on IPv6 security, which is available at academy.ripe.net. So if you are interested, feel free to give it a try. And yeah, deploying IPv6 is definitely something that has to be done, but we are doing it mostly in order to get rid of IPv4, because IPv4 is not scalable anymore. So deploying IPv6 shouldn't be the last step. It should be the first step. The final step should be to turn off IPv4. So we should really think about how to build our networks in a way that IPv4 is no longer necessary. Once you turn it off, the sooner you do it, the more money you can get by selling those IPv4 addresses on market. It's like the nice, let's say, business point of view idea. Also, the thing is that if you have just dual stack IPv4 and IPv6, this dual stack very often masks problem with IPv6 because there's this feature called happy eyeballs that web browsers have particularly, that they can fast switch from broken v6 to working v4 without user noticing anything. And that means that there can be IPv6 broken for months and nobody notices, whereas if IPv4 breaks, it's fixed within minutes or hours. So that is also another reason why undeploying v4 is really good idea, and you should really start maybe not with your public facing service, but at least in private networks that are management only, that are only accessible to people that already have to use VPN. So if they have to use VPN, you can provide them with v6, and if you can provide them with v6, why to have management on dual stack or v4? Just switch to v6. And another thing that is really good exercise, and I would recommend to any like techie, is to deploy v6 only network in your home or office network and use it for day-to-day operations. So you find out which networks, which devices have problems with that, which services can have problems with that, because without reporting issues and without working out what doesn't work, this will never get better. Somebody has to start with it, and this is like nice thing to start with. And in case I didn't convince you yet, I have this graph of IPv4 auctions, which shows the price in dollars per IPv4 address. And well, a little bit appeasing is that it's now not steadily growing. It's a little bit more on a plateau, but you can see that this is the like only future that you can see with IPv4. It's not going to get better by any means. There is indeed no plan C. We don't have anything else than IPv6 for growth of the internet. The good news is it's not a protocol of the future. It's already deployed in quite large scale, and it seems to be working. There are even bigger IPv6 only plans, and there are a few IPv6 only projects. For instance, last year, this archive web page of United States, of the White House web pages, they put this yellow banner on top of it saying that as part of the ongoing project, we are now switching off IPv4 on this website, so you can only find it if you have v6. And you can expect that this is going to happen. This is going to happen in more and more places, and well, hopefully we will get to the point where IPv4 will not be always necessary. That's the end of my short talk. In case you have any questions, feel free to ask.
Okay, we do have questions on the board in the queue, and I believe we have some over the net. Okay.
Alish Chasser. RIPE should be, I think, a big promoter for IPv6 deployment. And why we have here RIPE provided wireless network without IPv6 connection? It's IPv4 only.
Okay. So in your first part of the question, right, that RIPE or RIPE NCC should be more promotive of IPv6. Well, yes, we do whatever we can. We have this, for instance, for my department, which is learning and development, we do have this RIPE NCC Academy, which is e-learning platform for basic. We have course for basic IPv6. We have IPv6 security training course. We do face-to-face trainings. We have we have working groups on RIPE meetings. So like I would say I'm pretty confident that we as RIPE and CC do as much as possible. Regarding your second point, yes, I did notice that the Wi-Fi network here doesn't offer V6. This network is not operated by a RIPE meeting team. This is like sponsored by local host. I believe I'm not involved in that. I cannot give you like a proper answer to that. Yeah, but it more or less illustrates the situation of the fact that if somebody asks for internet, they just get IPv4, and this unfortunately is the unfortunate state of the things these days.
Okay, we can go on the next question.
We have one question from the online audience. From Gasper says, how do we get GitHub or Microsoft to make their services available on IPv6?
Yeah, that's a tough question. Yeah, we are really pushing hard as far as we can. Hopefully they will realize, like, it took Google also like, let's say maybe 10 years to start offering V6 on Google Cloud Platform, even though Google was the first company that started offering their content over V6, but not in their Google Cloud. And now it is. So it's not like, I would say it's not lost forever. But of course, everybody would like it to be much sooner than it is.
We all hope. I believe we are out of questions. That's correct. So, to the coffee break.
Thank you very much, and have a nice rest of the conference.
Okay, hello everyone. I hope you had your coffee. We'll start with a test with 100 questions. I knew I'd get your attention like that. No, a practical test. Okay, hello everyone. We are now entering the IXP panel session where we will hear experiences from 5 different IXPs in the SE region. And we will start with our friends from Romania, and they will present us with the latest updates they had in their IXP arena. So the floor is yours, Cristian.
Hello, everybody. I'm going to try to use this how do I do it again? Thank you. So this is a presentation I have given in Timișoara 3 years ago. How to use an internet exchange to broadcast TV channels using multicast. For us, it works just fine. We are using the IP environment to relay audio and video. I'm going to try to be short because Daniele told me that he wishes for more time. The idea is that using an internet exchange and a TV exchange with the same equipment provides for a platform where IP services and TV services can be sold one another. Okay, I have to click here. First of all, the benefits are that the IP infrastructure can be used to convey for higher quality of the transmissions, low latencies, simultaneous presence of multiple streams, of course, lower operation costs. Every member who is using the port will pay for a fee that will include both IP transit and TV streaming. It is highly reliable, and there is a high security and the full control with an application that will provide for easy access of the TV operators. We are using separate VLANs to transport the multicast traffic. We have a separate bandwidth allocation for that specific VLAN. The connection is constantly monitored between the provider and the operator, and both the operator and the broadcaster can be assured that the stream is completely unaltered from source to destination. Of course, being IP, we can acquire the stream from a lot of different locations and using different paths. There are two ways of providing the stream to operators. One is the manual way, when you have to send all the documentation and to demonstrate that all the retransmission agreements are valid. The second one is to use an automatic system. We have a TV exchange management platform. Basic, you just click, you upload your documents, and in 10 minutes, all the gates are open. Why TV exchange? Because we are already present in several cities in Romania, I mean big cities, where our members are already connected, so they don't need to have transport up to a central location like Bucharest to be able to have these streams. They can get these streams from localities very close to them. This is an update from 2020, when in 2019 we started, and in 2020 we had 18 TV channels and streams. All the streams were SD. And 2 years later, we have almost 100 TV channels and 133 streams. Many of these streams are starting to broadcast in SD and in HD as well. The access to this TV platform is completely free. There are no recurrent costs. There were operators who asked us, what if I want only TV? Well, it's okay, you just register as a member. And what fee do I pay? You pay the membership fee. But if you are coming and you are having access to the TV streams, why don't you interconnect also IPv4 and IPv6? And most of these TV operators also interconnected with IPv4 and IPv6, even if the traffic was not important. That's about it. I just wanted to tell you finally that it is a successful project. That was the main information I wanted to provide to you. If you have any questions and answers.
Don't see anyone in the queue.
Okay.
So we'll leave 20 seconds.
Thank you for
now.
your attention.
Thank you, Cristian. Now we go to Italy.
Unshare the slides. Let's see if, oh, okay. Someone unshared them for you. Let's see if this infernal machine works.
Yeah, so next we have Daniele from Italy speaking
So,
about their work in Albania and the
share.
ANIX. And we see your slides, so Daniele.
Yes,
yeah,
they're
the floor is
extremely
yours.
dark. So hopefully you can see them. Hello, my name is Daniele Arena, and I work for NaMeX, Internet Exchange Point in Rome, Italy. So I'm not from the region. I was adopted. And I apologize, I'm a bit rusty. It's been 2 years, more than 2 years, since I've been at a conference, and now I'm actually presenting, so it feels like I'm in Fight Club. Okay, so NaMeX is an internet exchange point in Rome, as I said, largest in central and southern Italy, very old, more than 400 gig peak, 186 connected networks, 3 sites in Rome, but we're not here to talk about NaMeX, we're here to talk about ANIX, which is the Albanian Neutral Internet Exchange. This is not the first time I presented this thing. I present this thing at SEE meetings. Some of you maybe were in Budva in 2017 when this was just a project. There was no neutral IXP in Albania at all at the time. And then in Timisoara in 2018 when together with Kledi, who's actually in the audience and at the time worked with us, we had managed to start up the project. So there's been no update since then, and that's why, thank you, Cristian, I asked for a little bit more time today to tell you what happened since. So what happened in these the first years, the creation of ANIX? So the first thing we did was we organized the first Albanian Network Operators Forum. There was no NOG at the time, but thanks to Jan, it was actually created then. And we managed to get some ISPs involved in actually creating the Internet Exchange. So, by the way, the first Albanian Network Operators Forum, I think I should acknowledge, was sponsored by RIPE NCC and also by ISOC. Shout out to Max there. And so we got ANIX up and running, and thanks to a lot of volunteering on volunteer effort. So NaMeX and PCH donated the peering switches. We got the collocation from RASH, which is the Albanian Academic Network, and volunteers, local volunteers and ISPs donated several pieces of hardware and their hands to actually make the IXP happen. So you can see the wonderful early graph, which shows a peak of about 50 megs, which was great for the startup with just 3 operators. But then what happened in the last 4 years? So there was decent growth. We managed to grow from no members at all to 19, or actually 18 plus 1, but I'll tell you later why the plus 1. 14 locals and 5 international players. And now we got a traffic peak of 15 gigs, which is not bad at all. As you can imagine, the major changes in membership happened when the international players came in. So as soon as someone came in from outside, then boom, there was some locals who said, "Can I join?" And some key numbers, a little bit different from just the traffic stats that I wanted to share with you. So it was kind of unexpected for me, but there's a sizable amount of local traffic. So 3/4 of the traffic is the OTTs that we have. But the last quarter, more or less, is local traffic, which is, I don't think it's that bad. We're covering about 20, almost 30% of the ASNs in Albania and Kosovo. And we're not in Kosovo, but it was very hard to split the Albanian and Kosovo ASNs. So that's why they're included. And we're covering about 1/5 of the routes in the region. And it's not huge, but it's not that bad. So there's a lot of margin for improvement, but it shows that I think we've reached kind of, we managed to reach a critical mass, I think. These are the members. So as I told you, most of them are local. The international players, you can probably spot them. There's Vodafone, there's Facebook, there's Hurricane Electric, there's PCH. And the +1 I told you about before is Netflix. Why? Because they're not officially a member of the exchange, but we managed to get some 2 OCAs, 2 caches that we host in our AS, and IX members can access Netflix content through our AS. So they're not directly on the exchange, but anyone who wants to get Netflix content then can. So we're counting them, but not exactly as members. So can you go? Yes. Current situation, snapshot. ANIX is powered by NaMeX. What does that mean? That we're basically managing all aspects of the internet exchange, except for the co-location, because the exchange is housed at RASH, the academic network. And because, well, mostly because they have, I think, the only neutral data center in Tirana, definitely, but probably in the whole country. So technical infrastructure, there's a whole new infrastructure that we managed to obtain thanks to the wonderful help, once again, of the Internet Society. And again, shout out to Max, who is here. We got EVPN VXLAN based IP fabric, so actually 2 spine and 2 leaf nodes. That's not bad. We got an OpenStack convergence, hyperconvergence cluster. We got network aggregation routing with a couple more routers, and we also made it possible to have private interconnects between ANIX members, so patch panels, etc. So this is the situation at the moment, and I was almost forgetting to mention that all of this is pro bono. That means that no one's getting any money from this. All the parties involved are basically investing in this initiative so far. We believe that at some point this has to become self-sustainable, but we're still trying to understand how to make it happen, hopefully at some point soon. A little bit of taking stock of what we've done in the last 4 years. We're thinking that ANIX is able to make some changes in the networking ecosystem in Albania. So first of all, we try to develop as much as possible the local community. As I said, we have the first network operators forum in 2017, then the NOG was created. So we had actually a NOG meeting. And then we also had IXP meetings in the last years. And even during the pandemic, we managed to have at least a couple of meetings. We hope to have a physical meeting later this year. We'll see about that. Transit prices. I know this is a tough spot in the region. There's quite high transit prices in Albania, but we think that this is changing, or at least has changed already a little bit. We provide the opportunity for carriers to establish in a neutral place where they can find many customers, and some of them can offer lower prices. So we think that the general pricing of transit is coming down. And obviously, as all IXs do, we're bringing international players, so they're closer to the ISPs, and we're lowering their cost and latency. But as a, let's say, final part of this presentation, I wanted to zoom out a bit. And we were thinking about the path between not just Albania, but the whole, Southeastern Europe, Balkans, and the rest of Europe. So we made some, very quick study, and it seems to us that most of the path, the trace routes, take the same route. And it typically goes through Frankfurt, Vienna, and or Budapest, Belgrade, Sofia. This is the way that most of the packets go. Not all of them, but most. So I took the wonderful tool provided by RIPE-NCC. It's called IXP Country Jedi. This tool uses Atlas probes. It's typically used inside a country. So you take Atlas probes inside a country and you run the trace routes between all the probes. And you check whether the traffic stays inside the country or goes outside. So I hacked the tool a little bit, and I tried to trace the routes between probes in Albania and probes in southern Italy, which is just across the Adriatic. So all the probes are in that small rectangle you can see, and this is what happened. So the trace routes go all over the place, and mostly they go through what I mentioned. So Milan, of course, because they're going out of Italy, and Frankfurt, Budapest, Sofia, Vienna, Belgrade, etc. So this is not just us noticing, but we're an internet exchange, so we speak with many players. And we had unprompted observations asking us, so is there another way to the Balkans that is not that usual way? Because it would be nice to have an alternative path, which could be across the Adriatic. And so we're not operators ourselves, but we looked at it a bit, and we noticed that there are a few submarine cables across the Adriatic. Not a lot. There's one between Italy and Croatia in the northern Adriatic, but there's quite a few in the southern parts of Italy, between the southern parts of Italy and Albania or Greece. So there's one between Italy and Albania, which is shared by incumbents, Italian, so Telecom Italia, or TIM or Sparkle on one side and Alp Telecom on the other. There's another one which is Gwen, and I think it goes to Greece, and I think it belongs to OTE. Then there's Italy-Greece one, and it belongs to Wizz Telecom, and it's recently been revamped. And there's a planned one, it's called Ionian, and it should be operational later this year. So we also find that there's growing interest in these cables to connect the Italy and the Balkans. And this is the other, this is the reason why, well, it's not the reason, but it's one of the reasons why NaMeX is actually starting an IXP in Bari. It's going to be its own IXP, not connected to Rome, not connected to Tirana, but it's going to cater to local operators and also international players because of this presence of fibers right from Bari to the other side of the Adriatic, and there's some also that go to Asia. And I was thinking while preparing this presentation that in Puglia, which is the region where Bari is, there is 4 million people, which is quite a lot. It's more than many Balkan countries. And that Bari is much southern than here and eastern than here. So actually, I'm not off topic because Bari is southeastern Europe in some ways. So if any of you are interested, we also got a website. You can look at it. The plan is to have the 40 racks ready at the end of April, and there's already a lot of operators who are joining. Last slide to show what kind of a vision we have, which is to have, as I said, an alternative path to the Balkans that passes through the south of Italy, and possibly have on one hand NaMeX Bari and on the other hand ANIX as gateways. Right on cue, time's up. And if any of you have any questions, otherwise. Thank you for listening.
Thank you, Daniele.
Yes, and now for our third speaker from North Macedonia, talking about the internet exchange there. Vlad will be giving us his update, so please go ahead.
Okay, let's see how technology works. It's easier when you're on the laptop, but I hope that we'll manage the usual modern way. So hello everyone, this is my regular update. I do almost every SA meeting, starting from SA4. And today we are going to show you how things are developing in North Macedonia. Danielle already helped us a lot about showing how important it is to have your international players inside and how difficult it is to sometimes get fiber. So let's start up and see how we are going. So some history. IXP.mk was born in 2018. We are quite young and we started with only 3 peers. The university, the faculty, and one private company, which had only their own services to show with their SN. In 2019, with the help and support of ISOC, we got 2 new switches and some optics to start things moving the right way. And we got the same year 2 new peers, smaller ISPs, which saw the chance to improve their services given to their customers. And then I was here in the same venue for a different reason, and it was the last time I was presenting physically. That's in the beginning of 2019, where COVID-19 struck. And this is now what we have, or was happening the last 2 years. So year 2020, Ministry of Health declares the pandemic, and Ministry of Education stops the process. And the faculty had only 7 days to switch all of its faculty things over the internet, over our own platform. We already had our links, which was one from GÉANT and one from a commercial ISP. And of course, people started to work from home, regular outages, and latency was imminent in the working days, especially since all our 5,000 students went back at home all around the country. We had to contact Macedonian Telecom, and we got this very disturbing information that because of COVID, their upstream capacity is quite maxed out. And the first chance to get upgrades from their part is usually in the time of 60+ days, which in that time was completely inappropriate and problematic. And because of then, in the middle of March, in a 2.5-day marathon of them lighting up a very old optic cable, which was not in service for 15 years, they joined the IXP. Next month, 2 other smaller IXP joined, and we have our first online exam week in June 2020, and you can see the graphs. And yes, we are seeing almost 250 megabits of traffic over the exchange, mainly for traffic going to the system of the faculty. So it was a pretty interesting start. Then in August, just before the first big exam in September, we had the second biggest operator, A1 Macedonia, to join the IXP.mk. And after that, cable company joins. We got a new donation from ISOC, a third switch and an optical MUX to have a third point of presence to ease access. This was the idea that we will select one of the data centers from operators who are more neutral and they have a lot of rack space. The problem was that black fiber was pretty much problematic, so we managed to get a single strain of black fiber. And because it was difficult for the pricing, we asked this to be purchased in a contract by a private company for private usage, and then they actually allow us to use that as part of the IXP. We started to plan because of this that we need to create a fiber ring between the 3 POPs or the 3 switches in 3 different places in Skopje. Year 2021, we got the MUX and the switches. We got online, and we also started a tender procedure to get those leased fibers for the fiber ring. Unfortunately, because of legal and bureaucracy reasons, actually the government decided that they're going to lower the expenditure of equipment and services. We got an order that we are not allowed to purchase this, and we had to stop the procedure. And in the meantime, at the end of the year, we got our PCH node and actually managed to get it online in the beginning of this year. And this is quite interesting, but the faculty decided that even the next school year, which is currently in the middle, it's going to be completely online. So this is our our 5th semester that we are completely online with classes, exams and everything. And you can see how that started to look on the graph, and our daily record was January 2021, when we had 1.2 gigabit of traffic because of exams. What we expect in this year, almost a quarter past, we are restarting the tender procedure to raise the fiber ring. We got donation from ISOC about hardware for the K route, so we are provisioning a K route. We got Neotel to join. We have to plan a bit of migrations with them because they joined in an unstandard way, and their ZTE equipment sometimes sends some very strange packets. This is our general daily graph from time to time when there are no exams. Exam week ended last week, so this is from this morning, and you can see that traffic is in the level of usual. Around the peak is around 600 megabits, and the rest is standard. And here most of the traffic is again our faculty system. So as Daniel already mentioned, and we also see here what is the future. The main goal is to keep things running, and until now we have 0 incidents, and we tend to remain in that arena. We need to get some upstream capacity for the IXP itself, and this could not cost a fortune per month because we actually can't pay for it. And as a faculty, it's very difficult because we have to get a tender procedure, and in that procedures, we're actually limited only to operators which are registered and operating in Macedonia. So this creates a serious price problems in getting 10G or several times of 10G. We managed to secure donation for 10G from one of the operators who joined the IXP and are supporting us. And we are now trying to provision that to work. But as soon as we got this, we understood that the next time we need to get 10G more out of that operator or 10G or more from other operators, we will be in a situation that we would need a core router for the services that are running over the IXP, because the current situation is that we have the faculty core router, which is a VM, and it works, but sometimes getting a lot of traffic over it, it's a bit of a stressful situation. The last 2 points, actually 3 points. The third we upgraded IXP Manager to the latest. We usually do this in a way that we create a hackathon with our students, and they follow the upgrade procedures. And if something breaks, we get support from the friendly people of ANIX, which are the authors, and generally the students learn how they can manage important application like this. And the last 2 things is what is planned for this year. So we definitely need to pump up the IPv6 part. Our root servers are ready, our faculty is ready, but no one else is. And it's a bit of a strange situation. Even some of the operators who had IPv6 capacity before, in the last 2 years, maybe because of COVID, maybe because of other things, they dropped this. So they have almost zero visibility in the IPv6 domain. And since things are getting better with the COVID-19, our plan is that we are planning our first technical meeting, which will probably be the start of the NOC.mk in the, let's say, September-ish or later time today. So this is the quick version, and I'm here for questions if there are some. And I have to ask Hisham to help on this because. And also the lights, because I don't see you guys. Ah, thank you.
See no questions at the mic.
Online?
Let me check online. Just a second. Nothing online as well. So
okay, thank you.
Thank you, Vladislav. And then for our next update, we have an update from SOX. So the Zoran, I think, is dialing in remote, right? Yeah, I see you on screen. Hello, Zoran.
Hello.
Yes, we'd love to hear from you the update from the Serbian exchange. So please go ahead.
Glad to. Can you hear me? Yes?
Yes, perfect. Go ahead.
Okay.
And we see your slides.
Okay. So I'm sorry that I cannot join you in Ljubljana. It was really my wish to come, because we did not see each other for, I don't know, 3 years. But okay, I hope that you're all enjoying good hospitality of Jan and other hosts. Regarding SOX, nothing much changed since the last virtual SEE meeting, but then again, a lot of things changed. Why? First of all, I will open with the notion that we need to adapt and to adopt. We have to adapt to the changes, and we have to adopt the reality. We are doing that since the day one. We started 12 years ago, and maybe that could be the first conclusion, so to say, that time is important, and it takes time for for an IXP to get traction, to grow. Right now we are in the neighborhood of 400 gigs. We are reaching for 500. Hopefully that we will catch it soon. Only a month ago our top traffic was 400. Only 6 months ago our top traffic was 300 gigabits. But going back 10 years, it was really difficult. We were struggling with megabits, a couple of gigabits, and then simply through the communication, through the constant presence in the conferences and in the community, we managed to raise awareness that peering is something worth paying for. Now, situation dramatically changed over the years. First years, it was like, okay, you are cheaper than global transit. And now, 10, 12 years later, the main notion is, okay, you are more reliable, you are more scalable, you are more secure than the global transit. So it took us time, really a lot of time, to explain all the benefits to local companies. It took us time to go to Vienna and to Sofia in order to connect to CDNs that were not willing to come to Belgrade. Why? Because Serbia, Belgrade is still not part of the EU, and the legislation is different and the legal framework is different. And when we spoke with, for example, Netflix 6 years ago, they told us, yes, we will come, but it takes time for us to do the legal due diligence, to do financial due diligence. You are 32nd country that we plan to come. And look, now, 5-6 years later, they are still not here. Okay, we are present in Sofia, we are present in Vienna, and we connect CDNs there, but also really a lot of CDNs came to Belgrade in the meantime. And CDNs are definitely the ones to thank for all this great increase of traffic. So we adopted to virtual workplace, to virtual classrooms, to virtual playgrounds, and we are really now in an excellent relationship with all the biggest CDNs that operate in the market. Second, also very important thing is the cooperation, and we managed to explain to all our members, to all our partners, that we take a really good care about their traffic. The whole network is done in high availability. We have 2 switches per every POP. We have 13 POPs. We are undergoing upgrade from N times 10 gig to N times 100 gig. And believe me, it costs a lot of money. If we only have 2 POPs, it would be like, okay, 2 months project, 50,000 euros, goodbye. But with 13 projects, we need to really upgrade a lot of DWDM capacity, a lot of switches, a lot of fibers, and again, it takes time. We invested really significant time, money, and effort into S-flow analysis software, and what you will see here on the slides is actually the user interface of our software that is chewing a lot of S-flow data and trying to suggest the way to make better business decisions, but also it's a first step toward the intrusion detection system. So we are here chewing really big data. We have even some aspects of machine learning, learning new fingerprints, new problems that occur on the internet are implemented into our software. So it is not just about the connectivity, it is also about the quality and the security of the connectivity. So you cannot imagine how many problems you will face once you go to 100 gig on your fiber optics. Really, the physics are no longer simple. Really, if you want to put DWDM system with N times 100 gig, and for example, this central slide, Teka Center THQ, it is the link between our 2 central POPs in Belgrade. It is now 140 gig in the backbone. It is 200 gig in capacity, and we are just finishing tender for n times 100 gig DWDM system. And it is complex. It is expensive, and it is really, really complex. On the other hand, we upgraded the western route toward Vienna to 200 gig. We upgraded the southern route to Telepoint in Sofia to 200 gig. We are also adding 2 more 100 gigs on both from a third operator because we diversified everything. Unlike Macedonia, we have no problem buying 100 gig capacity toward global internet, and we buy it from Cogent and from Hurricane Electric. They are our long-time partners, and we are really, really happy with what is going on. So 100 gig is a big step forward. Traffic is growing really, really nice. Now we are in the neighborhood of 500 gig. And unlike 5 years ago when we used software-based routers, we invested 2 years ago into Juniper MX 204. They are a little bit stubborn, but they are perfect routers, and they route like I don't know 180 gigs of traffic, no problem whatsoever. We upgraded the whole backbone to 100 gig switches. In those 2 central points, it is Juniper, and on the aggregation on smaller POPs, it is Arista. But we are also very happy with fiber store switches, which are in the smallest POPs. Coming back to the traffic itself and the analysis, Daniele mentioned that there are a lot of Kosovo and Albanian ISs. I can confirm that in our BGP table we also have a lot of ASs from Kosovo and from Albania. None of them are connected directly to us, but we see them either through our customers or through other internet exchanges that we cooperate with. In Sofia, we are connected with I don't know, 5 different internet exchanges, and in Vienna we are connected with 2. So we have 10 plus customers using 20 plus 100 gig ports, and so far the backbone is handling it really, really well. This has not changed really a lot. We focus on community meetings. We really focus on communication, collaboration, cooperation. Those are actually two syntagmas that we use to adopt and to adapt, and communication, collaboration, cooperation. That is the entry, that is the exit, that is everything in between. Because we are here just because we have the goodwill of our partners. So cash flow challenges. We are a private company. We invested really a lot in this COVID era, and we already faced some issues with debt collection, and we have quite huge investment. But okay, so far we are handling all the challenges. Further improvement of resilience, availability, and quality. Really, no need to emphasize that anymore. From the day one, we supported high availability, high resilience, dual stack. We support IPv6 from the very beginning. Unfortunately, the traffic level is low. Traffic level is like single-digit %. And again, not all of our members enabled IPv6, but I can proudly say that 80% of them enabled V6. Not a big traffic though, but okay, it is there. So once again, I cannot underestimate the importance of communication, collaboration, cooperation, and what it did in these 12 years. We all mentioned ISOC a couple of times. Yes, ISOC also helped us 10 years ago. They donated us 2 switches at the very important moment in time. And they helped us really a lot in acquiring 7 root servers, NetNode, ICANN, RIPE, Verisign, PCH. Really, a lot of them came because of good communication done via ISOC meetings, RIPE meetings, etc., etc. So again, as on the last SE meeting, surviving the change, and our biggest idea is to communicate even more, because we are really here just because of our partners. Next, we see that other IXPs are leaning toward system integrators, managed security service providers, and I hope that we will do the same, that business customers will slowly come to SOCs and start using services as they use in other big IXPs all around Europe. That's it. If you have any questions, I'm here.
Thank you, Zoran, for that. I don't see any online. Is there anybody from the floor that has questions? No, if not, then thank you very much. Applause. Thank you. And then for our final speaker for this session, we have Vladimir talking about the Montenegrin exchange. So please go ahead. We see you.
Samo sekund, moram nešto da odgovorim ovdje.
I think what's Zoran. Please, Vladimir.
Okay, thank you. Hello to all. My name is Vladimir Gazivoda. I am from University of Montenegro and represent Montenegrin Internet Exchange Point. I'm sorry I'm not able to attend the on-floor meeting, but some of my colleagues are there. So hello to you all. Okay, so Montenegrin Internet Exchange Point was established in 2015, and it consists of six members, because Montenegro is not a very large country, but with these six members, we are covering all major players in internet providers in Montenegro. So as for the 2021 and 2022, we have offered very limited connections. As you can see on this slide, it were 100 and download and 30 megabits upload, 100 megabits full connection, and 1 gigabit connection. And the internet exchange point was very low usage, but after each year, very progressive in the capacity of the internet links. But that all changed in COVID time. As you can see on this graph, this is the graphics for part of the 2021-2022, and you can see dramatic increase in bandwidth usage, almost on all our members, and especially you can see that it was peaked to 1 gigabit per second for most of the providers, and that was because, as you know, true nature of usage of ICT in the COVID time. What we noticed that all the faculties, all academic institutions transit from conventional teaching method to online method, and not only just the correspondence via email or online tests, but all the classes were held via the distance learning platform, and that especially means use of multimedia content. Also, especially in 2020, we had very strict rules regarding COVID, and there were many of population of Montenegro in homes, and what that means that they used more of the ICT technology, more demand of multimedia content, and not only just multimedia content that are from outside providers, but also multimedia content within the Montenegro. So reasons for increased traffic were, as I said, e-learning and online conference, increase in multimedia content, and what is expansion of provider reach toward customers. Many of them, I suppose, were introduced with very high load for outside multimedia content. So especially the online TV providers, and were allocated the content in the Montenegro. So that is that peak last year in the middle of the 2021. Okay, so what we had to do, you see, we have 1 giga connection options. Right now we are overcoming that issue with giving 2 or more connections to particularly per user. But thankful to ISOC, we have obtained 2 years ago, I think, Cisconnex's 10 gig switch. So it was necessary to acquire modules for interconnecting equipment in 10G and also connecting the customers. So we are now in the procedure to offer to our users 10G connections. As for the IPv6 was also introduced in Montenegro Inter-Exchange Point several years ago, but unfortunately IPv6 imprint in Montenegro is not very high. Only University of Montenegro is implementing IPv6, and only in the part of its network. Other providers are testing the ground, and I think they are planning for this year or maybe next year some larger actions toward IPv6. So Montenegro Internet Exchange Point is IPv6 ready, but it is not using at satisfactory level. Okay, thank you. It was very short.
Thank you for that, Vladimir. No questions from the remote. Are there any questions from the floor here? No? Well, so thanks again for that, Vladimir. And I also wanted to note something about all the exchanges that we've heard updates from. They do a lot of community work and community meetings. A lot of the NOGs in the region are revolved around the exchange. A lot of the training that we as RIPE NCC organize, we do that in cooperation with the IXPs here, and they host a lot of the meetings when we come into the region as well. So that's very much appreciated because of the efforts that they do within the community. I just wanted to note that, and a big part of the effort that I don't think they gave themselves justice that they do in the region here. And with that, I'm handing back to the chair. So please, Vlad.
Okay, so we finished our IXP part for today, and I have some great news based on the updated agenda. Next, you have a longer lunch break, so enjoy lunch.
Hello to everyone. Our next presenter is Tomek. He's talking about GA2, a modern DHCP. Tomek, please. Okay, the presentation is on. So, Tomek.
Okay, hello everyone. I'm Tomek Mrugalski, and today I will be talking about DHCP. So my adventure with DHCP started in 2003 as my master thesis. So I implemented Dibbler as the master thesis, and then kept developing it for I think 15 years after that. And some people liked it and used it. So this was the first complete implementation of the DHCP v6 spec. It was a v6 only implementation. So after a while, I joined ITF and started doing some stuff, wrote some specs, and for some reason they decided to publish it. I don't know why. So in 2011, I joined ISC. So as a first engineer that was working on something that became GÉANT. So my first assignment was to evaluate what are the problems with the current solution that ISC had, so the ISC DHCP. So it was a software that was started in 1995. There were many technical choices made that were maybe good in the mid-90s, but right now in 2020s, they are ridiculous. So the code was inherently single-threaded. It had its own memory management. The API to change anything was super complicated and required complex C structures. So you had to be a C programmer to understand how to use it. So, but it was very widely used, and it still is. So, but since GÉANT now is almost 11 years old, we decided to start phasing out the ISC DHCP. So, and the release that we did, 4.4.3, in March 2022, this was the last one with a client and a relay. So the upcoming 4.5.0, this will be server only. So I understand that there's still a large community of users using the client. It's unfortunate, but ISC is a small organization, and we have limited resources that we have to allocate wisely. So we've been developing this for what? That's like 27 years now, and we decided that okay, that's enough. So, but for the server part, I think it will be around for a while, but still, it's a good time to consider migration. So we are trying to make the transition as easy as possible. We came up with a migration assistant, which is a tool that you run on ISC DHCP configuration, and it will try to convert this to GÉANT. Of course, not everything is completely one-to-one conversible to new syntax, because this is one of the problems with ISC DHCP, is that the configuration syntax is basically Turing complete. So when I joined the company, someone told me a joke that you can solve towers of Hanoi in it. So, and I'm not sure whether this was really a joke or a truth. So anyway, if your config is super complicated, you won't be able to convert it. But at least this will give you a head start. There's a good presentation about this from Alan. He gave this talk on Nanox 76, so you can look it up. So, what are the benefits of GÉANT? Hold on. Okay, so the key differences between GÉANT and ISC DHCP are that there's an extensive modern REST API that you can use to do almost anything you would expect from a DHCP server. Also, we have separate backends. So if you want to, it can be almost as small as the old DHCP. You can keep everything in flat files, but if you want to, you can scale this to much bigger things. So you can use MySQL and Postgres databases. And you have also flexibility where you put various chunks of your configuration, where you put leases, reservations, and even the whole server configuration. Also, it's extensible. So there's a mechanism of optional libraries called hooks. So the concept is very similar to modules in Apache. And yeah, the code is open source. There are some commercial add-ons, and also the hook API. This is part of the open source. And there's, the last time I checked, there's 10 hooks implemented by people out there. So there's a small community growing around the code. And there's around 18, maybe 20 hooks provided by ISC. So also ISC provides easy to use packages for most common Linux distros. But of course, if you want to the source code, you know, the old-fashioned way, go to tarbors and compile everything on your own, it's absolutely still an option. We also have monthly releases, which is quite convenient if you want to, you know, keep up with the bleeding edge features. But if you want to, we also have stable releases that are roughly published once a year. Okay, so speaking of the API, right now the latest version of Kia has over 180 API commands, and they're ranging from very basic things like check the version you are running to get full configuration, get status, set the whole configuration, update subnets, reservations, inspect and manage leases, and whatever else you would imagine you would want to do from a modern DHCP server. So the API is well documented, so there's a link. So you might want to take a look. Okay, we also provide a sample client, which is very basic. Instead of this, you can use curl or whatever other tool that is able to send JSON over HTTP. So this is an example, a starting point. You ask Kia to get you a list of supported commands, and then you get a response. And in similar fashion, you can use the API for more advanced things. So we have a concept of backends. It's possible to configure Kia to use a database. You can use it if you want to go small. You can use a local CSV file, but you can also do a Postgres or MySQL. In the past, we also supported Cassandra, but this is now being retired. So the advantage is pretty obvious. You can then use whatever other tools you want to inspect the database, and also you can modify the database in the real time, and Kia will pick it up. So, like for example, if you have a device in your network that you want that you know that is like a broken cable modem, for example, and you know that it's out and you want to delete the lease, you can just use a SQL command to delete it, or use the API if you want to. So and the changes will be picked up instantly, so you don't need to restart anything. So it's also possible to deploy Kia in a way that you have a shared database with multiple servers connected to it, and they will share the database, and there won't be any conflicts. So with the backends, the whole thing is extensible. So in the sense that we're covering almost any aspect of DHCP server operation. So the most frequently changing elements are leases. So these are the address assignments, address and prefix assignments. And then you have host reservations when you say which devices should get which addresses and prefixes and options. And then the probably least frequently changing type of information is the configuration of the whole server. What are the subnets in your network? What are the pools? What are the client classes, and so on. So in September 2021, we released KIA 2.0. So I wanted to talk about a couple features that are now available. So the first one is to explain this, it requires a bit of history. So in KIA 1.8, we implemented multi-threading. So the packet processing became very fast. You could take advantage of multi-cores of your system. But the problem was that if you happen to be running HA, which is a pair of servers, the communication between servers was still very slow. So the communication was a single connection over Unix socket, over a single connection, a single HTTP connection to the other end, and the path in reverse. So in 2.0, we implemented direct communication. So there are multiple threads that are opening multiple direct HTTP connections between the servers and doing multiple updates in parallel. So this gives a huge performance boost. So these are the example performance results. If you want to take a look into more details, there's a link for page reports.kia.ic.org. There's a lot of details, including the configuration files and explanation how you can repeat the experiments on your own hardware. So in many cases, the speed up was over 10 times. Okay, so another thing that we recently added is TLS support. So you can do the API over TLS. So we have 3 modes. Okay, 2 practical modes. One is encryption, when the client verifies the server certificate. But then a better way is mutual authentication, when also the server verifies the client's certificate and will reject it if there is something wrong with that certificate. And this is the default if you enable TLS. Also, we implemented ability to connect to databases over TLS, because over time, the mode of operation is changing. So in the past, people assumed that DHCP is a local service, everything is local, and you trust everything in your network. But right now, more and more people are running more services in the cloud in different configurations, with a database not always being on the same machine as the DHCP, often in different container, and you want to have encryption for this. So for Postgres, this was possible with just Postgres configuration changes, and with MySQL, this required KIA code changes. So, but now both of them are possible. Okay, so another thing that we implemented is cache threshold. So this required to explain this, it requires a bit of reminder how the DHCP works. So when you assign a lease, there's a renew timer that you specify. Hey, you have this address for 2000 seconds, and you should renew it in 1000 seconds. But there are many broken clients that ignore this or miscalculate the time and start renewing early. Sometimes the more crazy ones, they start renewing immediately or after a couple of seconds. So, and in many cases, I remember one customer that said that 9% of their devices generated 50% of the DHCP traffic. So they had a lot of broken clients. So in Kia now you can configure cache threshold. So if the client comes in and tries to renew early, Kia doesn't do anything, just sends the old lease, and this is much faster. So your server still needs to deal with the traffic, but it's doing this much more efficient. So it's a nice optimization. Okay, and another thing that we implemented is a script hook. So many users came to us and say, okay, hey, I want Kia to do this and that. And the questions, the requests sometimes get more and more strange, or like very deployment specific. So we decided to come up with a mechanism that once anything changes about the leases, we can call a script, and then you can do whatever you want with the integration with your system. Of course, the most popular case for this is to do the routing table update after prefix delegation. So, but obviously it's not limited to that. You can do whatever you want. Okay, so another thing that we've been developing for Kia is Stork. So this is a dashboard that is evolving. So right now it's a dashboard, but very soon it will have some management capabilities, and then it will continue to grow. So the idea is that you have one Stork server, and then you deploy Stork agents for every machine that is running either Kia or Bind. And the agents will gather statistics and different parameters of the system, and will report it to Stork server, which will aggregate the data, and then you have a nice web interface to see what's going on. And there's also a capability to export the data to Prometheus and to Grafana. In fact, you can even run just the agent and don't have the server, and tell it to just export the data to Prometheus. So you can use it as in the simplest deployment. This can be used as a statistics exporter. So there's a lot of parameters that are being monitored. Starting with the simple ones. What's the version of the software being used? What hooks are installed? What's the CPU utilization, memory usage, and so on. And we also, these are part of like generic system monitoring. So there is nothing fancy about it. What is nice about Stork is that it has a lot of DHCP specific monitoring aspects, like what's your subnet utilization, what's the state of your AHA, what's the data in your log files that are specific to certain servers, and the DHCP specific statistics, like how many exchanges were handled, how many queries per second, how many addresses were declined, and so on. So for Stork, we have a similar approach as with Kia. We have monthly releases, and yeah, as I mentioned, this is a dashboard for now, but the configuration management is coming up soon. This is an example screenshot which showing pools and some warnings when the pool utilization is high. And this is probably more interesting. This gives you a deep insight into what's going on with your high availability status. So whether the heartbeat is working, when was the last time the server were reached, how the relationship looks from one server and from another. So this is pretty useful, I think. So, and finally, we have a couple dashboards for Grafana that are taking advantage of the statistics. But of course, with Grafana, it's super easy to tweak this and adapt this to your specific needs. So, and this is open source, so we encourage people to participate. It's possible to send patches, send feature requests and bug reports. Of course, we don't promise that we will fix everything. We have limited resources, but we'll try. So, and that's basically it. So, are there any questions?
Is there a question? Okay. Jan George is in the queue. Who is on mic? Please, Jan.
It works. Jan George, 6Connect. Tomek, thank you. Thank you also for coming, giving this great presentation. I have two questions. Why the name Kia? I know that's a bird from Australia or New Zealand, but why Kia? And second question, the serious one is, where you want to develop this? What do you, in which way you want to go with adding new features? What do you want to do with this now?
Okay, so the first thing is I'm a nature guy, so I like outdoors. So my previous DHCP server was called Dibbler. This is a small marsupial living in Australia, and Kia is a parrot in New Zealand. So it's very clever. So and I liked it, and also it's short. And back then there was no other software named Kia. It's short to type, easy to pronounce. So I thought, okay, that's a good name. And that's, by the way, why the next project was called Stork. So it's a bird. Okay, and regarding where I want to develop the software, sorry, it very much depends on the users. So we have a lot of feature requests and bug reports. So we're trying to make this as flexible as possible. So historically, we started, with the biggest deployments because this is where we could get funding the easiest, and now we are trying to expand to smaller and smaller cases without abandoning our large deployments. And also, right now we are getting more and more feature requests from, I would say, enterprise environments. So, like access control, audits, traceability, this kind of stuff.
Cool. Thank you.
Sure.
Okay, we have another question from Gasper Fele George. I will read it. Will you accept patches which implement functionalities from premium plugins?
Okay, so that's a tricky one. I cannot really give, like a wildcard answer that yes or no. But the idea is that we came up with this business model that we have to fund the software somehow. So it's possible to, buy the hooks. When you buy the hooks, you get the source code. So it's still commercial license, but you have the access to source code, and there's even the developer's guide for every hook. So in principle, it's easy to buy it, re-implement it, because you know how exactly it's working, and then say, okay, now it's open source. So we cannot let this happen. But on the other hand, this is always a trade-off. So we are not a greedy for-profit organization. So we are trying to make sure that in smaller deployments, universities and such, they can fully take advantage of Kia of the features. So we are trying not to limit essential functionalities.
Okay, thank you. Is there any other questions? Thank you, Tomek.
Thank you.
Our next speaker is Steffann with his hat of being from 6 Connect. Take it away. Let's welcome Sander.
Okay, that should be the right presentation. Looks like it. Okay, hi everybody. So last year I started working for 6Connect, company that makes IPAM software, IP address management, DHCP, DNS, the whole thing. I'm working there with my good friend Jan Zors, and Jan was like, hey, you know, we do a lot of DNS stuff. Let's do a road trip. So, you know, we work for a company that has customers all over the world. We do DNS. Shouldn't we do like a global DNS platform that we can offer to our customers maybe? So yeah, so how do you build a global DNS platform? Well, these days you use Anycast. So we came up with this idea and had some thoughts on it. And we mentioned this to the commercial people in the company. And they were like, we might actually have some customers for this. Go ahead. Play with it, try it, see if we can make this work. So, you know, we were on this road trip and we were like, okay, let's make a roadmap. Let's think about how we are going to build this. So we build a prototype, set up some measurements, you know, do a bit of fiddling with the settings. That should be it, right? That can't be that hard. So very optimistically, we just started building. Now, the first bit was like, okay, what are we going to use? Like we can use Bind, Node DNS, NSD, Power DNS. There's all kinds of great software out there. And then we were like, whatever, let's just use all of them. Just run a server with all 4 of them with DNS dist in the front. DNS dist has some nice scripting features that we can use. So let's build something that has everything. You know, we can always remove parts if they don't work. So that was the start. For the Anycast, we had to have a BGP daemon on every DNS node because obviously, if something goes wrong, you want the route to disappear. So we chose to run BERT on every node. Of course, we're lazy, so we put everything in Ansible, so we didn't have to do too much typing every time we wanted to roll out a new node. And of course, this is Jan. He loves his shell scripting, so lots of set and awk and bash and stuff like that. I mean, yesterday we were wearing old school T-shirts. I mean, it's true. So how did we build this? So we have a node at the top that has a DNS dist. Under that are the 4 different name servers. We actually use of course, our own provisioning system to provision the zones. It connects over SSH, pushes out the zone file, and then a local script makes sure that that zone file ends up in the configuration of all the 4 backends. And then we wrote a script called Damocles, like the one with the sword. So that's like the sword of Damocles hanging over the DNS server. If you go wrong, we will let the sword drop and you will disappear. So this little setup we deployed, and this was prototype version 1. So where we're going to deploy this? So we already had some servers in Fremont in the US. Jan had built a cluster here in Ljubljana, and I had just built a backup cluster in Apeldoorn, my hometown in the Netherlands. So of course, with Anycast, you want a bit better distribution around the world. But you know, to test the concepts, we were like, okay, you know, this is a good start. But then, okay, we have to make some choices. What IP addresses are we using? Well, you have to announce separate routes. You want some redundancy. So we decided that we would announce 3v4 and 3v6 prefixes. And we would have 3 nodes in every location that could take over from each other to provide some redundancy on each side as well as between the sides globally. And actually, one of the questions that always comes up with Anycast is which AS number do you use? Because technically, you can either announce everything from one AS number, or you can use a different AS number for every site. And it has advantages and disadvantages. So the advantage of using one AS number is that you can communicate your peering policy a lot easier. You have your one AS, you announce these 3 prefixes, that's it. The advantage of using separate AS numbers is that you get some more information from the, some clearer information from the routing tables. So if you look at the routing tables, you look at the AS number, you know which cluster is announcing it. You don't have to look any further. Also, an advantage of using separate AS numbers is that you can actually see your own announcements. Because usually in a BGP border router, it will ignore all the routes that come in that already have its own AS number in the path. This is the standard loop prevention mechanism. So if you actually want to see your own routes, you'd have to accept routes that have your AS number in it already, so you can look at your own routes. In the end, we chose to use one AS number and just deal with that. It was the part about just having a clear routing policy, just one well-known AS number was a lot easier than deploying a dozen AS numbers all around the world. So how do we announce it? We have 3 nodes in every cluster. The primary node announces its own /24 and 48 with a high priority, and it announces the /24 and the /48 of the second node with a lower priority. The second node has its own with a high priority, and that of the third node with a low priority. And the third node has its own with a high priority, and that of the first node with a low priority. So every node has one backup node. And if they're all online, their own prefixes are announced. So prefix 1 goes to node 1, prefix 2 goes to node 2, prefix 3 goes to node 3, done. But if one node fails, then the backup route of the other node will take over. Now, we have several ways of deploying this. For example, we are using some virtual machines in Vultr. So our BGP upstream is the Vultr router. So in that case, we are talking eBGP to this router. So we can't use things like local pref. So we just use AS path prepending. In our own data centers, we have our own border routers. So we're using iBGP to talk to our own border routers. So at that point, we can just use local pref to determine what is the highest priority and what is the lowest priority. But the concept stays the same, just the mechanism, just a simple little block in Ansible that's like, if the remote AS is this AS, then do this, otherwise do that. And that's how we deployed it. Now, immediately we started noticing that this DNS service wasn't as stable as we'd expected. We were a little bit optimistic, and there were some, like I said in the slide, some unexpected potholes in the roads, and our road trip wasn't going as smoothly as planned. So why? How do you figure this out? Because you're announcing the same prefix with the same AS number from different locations. You start doing lots of trace routes, looking at route views, RIPE atlas information, trying to figure out why doesn't this work. Sneak preview. Some of the things that didn't work was we messed up one of our firewall filters in one of the firewalls, and we're dropping some traffic, or our route policies weren't correct, or we were just experimenting and we made mistakes. But yeah, how do you solve this? And then we realized that it's really hard if you have already 3 locations. It already is kind of difficult to really figure out what's going on. So in the meantime, we already decided, well, we know three locations isn't enough, so we just also added some VMs in Tokyo to the setup. Later, we also added some in Miami and some like in other places. But yeah, we were having fun. So while we were thinking about the monitoring, we were also already expanding further. May not be the easiest to debug, but it was a lot of fun. And of course, we just had our own labs domain that no single customer uses, only used for internal stuff that we were testing with. So hey, eat your own dog food. Just throw our own domain on our Anycast platform. What could possibly go wrong? So we were starting to monitor this. We had the Damocles process in making sure that at least the local node was sane. We were using our own 6Connect provision software to push out the zones to the different nodes. So we actually checked that was all working perfectly. But then beyond that, it got a bit shaky. So we were only monitoring port 53, which was the DNS dist port. So we're monitoring what the customer sees, but we weren't even monitoring our own backend services. As long as something was running, the node was fine. And we were using LibreNMS with some custom code to keep track of what DNS dist was doing and what was going on there. So very rudimentary monitoring, and this was clearly not enough. So again, this little road trip, we're already having fun. Let's take the scenic route. So what else could we do? And we started thinking about what would be suitable for this Anycast platform. We're doing authoritative DNS. Recursive DNS shouldn't be that much harder, right? You know, that's just some other DNS software, some different settings, kind of the same thing. We also have a cloud-hosted version of our IPAM systems. Could we Anycast that? Like there's things like GaleraDB, where you can have multi-master MySQL setups. You know, could we just run our database all around the world and have everything sync with each other? And what impact would that have on performance? And how usable would that be? And what problems would we encounter? So we did a lot of brainstorming, playing around with this. And then also for the mail, like, oh, you know, if we just have a bunch of MX hosts, why don't we just let all of the Anycast locations be an MX node, and we have a really redundant mail system? We can even synchronize the mailboxes between different hosts. Like, we just went crazy with ideas, like what could we do with this? And a lot of these things we started experimenting with and playing with. None of it is ever close to production, but you know, it's really interesting what you can learn about the technology and about the stability of routing, of TCP, by doing all these crazy things. Because everybody says, oh, but Anycast, it's good for UDP sessions, for quick query response protocols, but longer lasting sessions, it's really unstable. So we're actually, once we get things a bit more stable, we're just going to test it. Like, how unstable? Which parts of the world are more stable than others? So we're not nearly done this. This is just a list of ideas that we will be exploring in the next year or so. Then we were thinking, okay, if we're going to run this these weird things in many locations, do we need it to run everywhere, or can we run it in a subset? Maybe some services can be hosted in just a few locations with some load balancers in the other locations that just redirect the traffic to one of the master nodes. We looked at HA proxy and Nginx. So yeah, like I said, there's lots of experimenting and thinking and just doing crazy things just to see if it works. Now, one of the things you run into, and this is something you might run into with all the encrypted DNS things as well, not just the wild ideas, is how do you get your TLS certificates? These days, everybody's like, oh, use Let's Encrypt. But if you're using Anycast, then the server running the Let's Encrypt client is probably not the server that Let's Encrypt is going to send its validation request to. So how do you solve that? Well, it actually turns out that Let's Encrypt can respects redirects in HTTP. So if you on every Anycast node say, oh, just if you get this request for this .well-known Acme URL, redirect it to this central server, and then you can run your Let's Encrypt on that server, and that server can then use SSH, for example, to push out the generated certificates again to the Anycast nodes. So these are things that they're not difficult, but they make the whole concept a little bit difficult, and you're running into a lot of these tiny problems that all together actually cause some headaches. But all of them can be solved. But we still have this dilemma. We're announcing these routes. We have nobody who can, we have people who can't see any of the routes. We have people on one side of the world not seeing the route right next door, but seeing the route from the other side of the world. And we didn't even know, are we globally visible? Are there places where no routes are being seen? Are there places where they see routes, but they black hole? The traffic just gets lost. And of course, you want to know that the traffic goes to, if not the most optimal site, at least reasonably close. But you don't want traffic from Asia ending up in the US, or traffic from Europe ending up in Asia. And this was happening a lot, actually. We could see there was not enough consistency in that. So there were many detours here, like traffic going in weird places. And how do you find this out? RIPE Atlas is a really useful tool, but to get a really good view on a bigger and bigger system, it became quite hard. So Jan was in the Netherlands. Remco lives right next door, well, 20 minutes away by car. So we were just stopping by at Remco's place for a nice drink. We had a nice chat. And then it turns out that Remco is doing this thing called link state, which specializes in measuring network reachability and Anycast all And he also had a nice bottle of whiskey that helped. So we had a nice evening just chatting about all these ideas we were having and all the fun we were having with just randomly experimenting with things. And Remco thought he might be able to help us a little bit. Of course, at that point, you're just chatting over whiskey. You have all these nice ideas, and then you have to take a step back and it's like, okay, what is it that we actually want? Because just random stuff is all fun when you're doing a little bit of engineering and research, but if you're actually talking to somebody who's running a company, they start asking difficult questions like, which metrics do you want and what are your KPIs? And Jan and I didn't even think about that. We just wanted to experiment and see how far we'd get. So we thought a bit and we came down to, okay, we want to know where are the prefixes visible? Are we actually visible? Are people getting all three of them? We want to know what they see. So which Anycast node is used by which network? And then hello Siri, stop it. It's fine. No, it's just, so my phone just thought I was talking to it, so it starts talking back. It's not, it's silly. So yeah, so we want to know what announcements people see. We want to know where is the user, which server are they using, what is the closest server, what are the conditions of the network around that, what is the latency. So we started looking at all of this, and of course, where are the black holes? Because if you start announcing your zone and people just can't reach the authoritative DNS, then you're just disappearing from the internet. So these were the main questions we wanted answered. And I won't answer them right now because that will be the next presentation. There's a reason we put them back to back. So yeah, we need something to make it better. And initially, when we had our first couple of nodes, you can see the US was quite covered. Europe was well covered. The node in Japan was taking care of the northern bit of Asia. But yeah, you know, we're privileged white men, and we're only looking at the northern hemisphere. If you look at the southern hemisphere, it's horrible. We're really delivering a bad performance there. And this is actually a map that came out of Remco's system. So when we saw this, we immediately knew we had to start doing something in the southern hemisphere. And that is my last slide. So I see we have 10 minutes left for questions. So any questions?
I may not have given a lot of answers, but I hope I raised some interesting questions as well for you.
Hi, Žiga here. I saw that you are running BGP with /24 prefix.
Yes.
I'm surprised to see that. I would expect just one prefix, so let's say /32.
You cannot route that on the internet. The moment you start announcing something that is smaller, so a longer prefix, your route just disappears.
Of course, but you don't need to do the BGP peering directly out of the internet.
If you want your Anycast node to be reachable from the internet, then the internet needs to see a route. And for the internet to see a route, it has to be a /24. It's a massive waste of IP space, but yeah.
Okay.
Luckily, we had some. We still had a couple of /24s we could use.
I have a second question. You focused mostly about the routing to these three appliances that you showed. What about the interface where you put the data in? So the A records, for example.
Yeah.
Just a moment.
Okay.
For the record, could you please state your name and affiliation?
I'm sorry, Žiga here from SRC company, local.
Yeah, so that system is actually our own system. That is what 6Connect has been building for 12 years now. So that system is where all the records are managed and where all the zones are made, where the DNSSEC signing is done. So that's actually our internal system. And I haven't done a lot of work on that. Jan and I are mostly on the networking side and the systems side. But if you want to know more about it, behind you are three people sitting there in a row. They're actually some of the developers of this system. So if you want to know more about that, please go talk to them.
There is one question online. It is from Sergey Miesuyedov and from NetArt Group, and he's asking, were your Anycast performance measured with UDP only or also with TCP? Can you estimate the amount of TCP sessions which were not established due to BGP deviations?
That's a really good question. We haven't looked a lot at that. However, I do know that the system that Remco has built is doing TCP measurements. So, which is basically a worst case for DNS. So, most of the measurements we have are TCP. We do have our own UDP measurements just for, and we send those to the unicast addresses of the nodes. So we measure all of them from our own data centers. We haven't looked at the failure rate. How many UDP sessions that had the what's it called, the truncated flag set were not followed up by a TCP session. So it's actually a really good question, and we'll start paying attention to that and come back at a future meeting.
I would just like to add, as a co-author of all this mess, since we submitted the presentation, we also added the XFR way of pushing the data to the Anycast, mainly because we were asked to help out with Ukraine.ua CCTLD to reinforce the infrastructure, and we are now putting .ua as a first CCTLD for free on this Anycast system, just to help them out. Thank you.
Yeah. I have to note on that one that the reason, like I said in the beginning, we're just pushing them over SSH. The reason we're not doing that for .ua and especially .com.ua is that these are quite massive zones. You're talking about millions of records. So you really want to send updates over IXFR and not AXFR or SSH every time. So that's the reason we've actually been expanding the platform to also handle notifies and trigger the backends to do their updates and stuff like that. Any more questions? Thank you.
Thank you. Our next presenter is Remco from Asteroid International and Link State. It's about for those about to Anycast.
Hello, good afternoon, everyone. It's good to be back on the stage. It's good to be in front of people again. After this being absolutely banned for a decade, I'm now presenting from my own laptop again. Can you imagine? The title of this presentation, for those about to Anycast, or dazed and confused, depending on where you are in deploying this. And why is that? Well, let's first start talking. First, a little bit of an introduction of what I ended up doing lately. Measuring at internet scale. The internet has over 10 billion devices and being used by almost 5 billion people on the internet. So if you want to get statistically relevant data about all of those end users and what they're seeing, you need an internet scale number of viewpoints, and that's not hundreds or thousands. You need hundreds of millions in order for that to be statistically relevant. And you need to have a distribution that more or less mimics that global distribution. So what we ended up building was a platform where we can continuously measure network, well, initially performance, but other things as well, obviously, from a pool of hundreds of millions of end user connections. I'm not going to go into the details of how exactly we do that. Rest assured, it's all above the table, of course. The interesting thing is that as Jan and Sander were having whiskey at my place, and it was a very nice bottle, it turns out that one of the internal test cases that we were building this stuff against happened to be a global Anycast network that we built for development purposes. Now, let's talk about a little bit about what do you want to achieve with Anycast. And Anycast is one of the hardest engineering problems on the internet. BGP in the way it's configured for unicast BGP sort of announces your hopes and dreams to the internet of where would I like you to send my traffic, and a lot of your optimization on your network side is how do I push my bits out to the internet. The key thing about Anycast and how Anycast is very fundamentally different from unicast is with Anycast, it's not the outbound path that you're fundamentally interested in optimizing. You want the inbound path, you want the reverse path to work. And you want that to have no black holes, no loops. And you can't just test from your side. You can't just send a ping from a unicast address and just expect that to work. You have to make sure that your inbound traffic ends up in the right place. And in order to define what the right place is, you need to have sort of the defined intent that you can build against. So designing what should go where. And you can determine that by geography or service level objectives, speed, latency, whatever you want. So this is the dream. I have a bunch of Anycast nodes, and they're all over the planet, and they all serve their own little part of the universe. And there's some strategic overlap where you want to have diversity of services, and that's pretty much it. This is your dream. And then you wake up to this. And so, I mean, let's see what's going on here. Let's see if we can sort of dissect what's happening in this picture. And of course, this picture is fictitious, but it's based on a true story. So let's go, let's start with yellow. Yellow is a nice color. So yellow is the POP on the West Coast. Let's call it Silicon Valley. And the Silicon Valley POP is pretty good at serving sort of the West Coast of the US. Turns out it's also serving like half of Asia, and it is pretty dominant for the most of South America. Now, then we have the red dot, which is probably in Amsterdam or something like that, and is well connected to a whole bunch of exchanges. It has direct adjacencies to thousands of networks, and is therefore extremely visible all over Europe, but also all over North and South America and large parts of Africa, and therefore draws a whole bunch of traffic into that area. Then North America looks pretty okay. The green one, the blue dot, which is your Sydney POP, which you were hoping would serve sort of the Asia Pacific, the Pacific part of the Asia Pacific region. And oddly enough, you see people from Moscow ending up there, and more worrisome people from the Caribbean going there. Your POP in the Middle East turns out to be mostly ineffective, even for people inside of the region. And you can see the picture from there. And what's even worse, what are your network monitoring systems telling you? They're telling you this: hey, I have these POPs and they're all online. So Jan and Sander came over and started outlining their issues with deploying Anycast, and I told them, so step into my office. Do you maybe mean something like this? And they were like, what are we looking at? And I'll just go through some of these things quickly. So measuring from the client side was, which POP do my users end up in the last hour? So if I'm an end user in Brazil, where do I go? And then it turns out in this case, it's the POP in Miami. And you see that this is a picture from our development Anycast network, which is a 100% unoptimized Anycast network. So it has all the bugs and errors and mistakes in it by design, because we're using it as a development tool. So you see that it somewhat works, but it's also pretty bad in some other cases. There's another interesting thing is, if my traffic shows up at a POP, what kind of round trip has it achieved? How far did the traffic travel? And this is a histogram of round trip versus number of times we've seen that round trip, or somewhere in that bucket. And basically all of the stuff to the left is good, and everything that's further to the right is not so great. So what you can see in here is that there's these interesting blips on that histogram that show that there's an Anycast POP out there that is probably serving or ending up in places where it shouldn't be. So you see that dip just in the middle, and you see the one on the extreme right. And the one on the left-hand side, I mean, that's something you might want to optimize for. And it could still be within whatever kind of criteria you have set for yourself in what you want to do with that traffic. For DNS, you have a timeout of 500 milliseconds for getting all of the queries out of the way to get a response. So you have a bit of time, but you also don't want to waste too much of it. So that's less concerning. But the one on the right is definitely of a major concern. And so you want to see what happened and why that POP in Tokyo is serving traffic from the other side of the world. Then again, here's another way of looking at it. So what kind of TTLs, what kind of hop count do we see on this traffic? And again, I mean, it's a distribution. The further to the left you go, the better it gets. I mean, I mean, you're not going to find anyone realistically under 4 hops away from your Anycast node. Otherwise, they'd be sitting in the data center next to you. So anywhere between 4 and 10 is fine. But as we found out, I mean, just looking at this is actual data, is some parts of the Comcast network in the US have seriously weird routing and towards my Anycast. And you can tell because it creates a hop count of somewhere between 20 and 30. Which is insanely far by current internet standards. More on the managerial side, so am I hitting my performance objectives? To Sergey's question, how much traffic is actually ending up in a black hole? Well, we can tell. You can also tell what kind of average round trip, what kind of performance am I hitting? What kind of excess distance am I looking at? And actually, you should see excess distance as I have a number of POPs, I have an end user, and that end user can go to one of these Anycast endpoints. But is it going to the right one? And what is the right one? And if it's not going to the right one, how much further than the closest one did it actually go? And in this case, it's actually a fairly modest 336 kilometers. And then finally, the intent match is if you've defined what countries and what geographies you're supposed to be serving from any location, how well does that match up with what reality is bringing you? And of course, what's my homework? Because if you're an engineering department, you need to know what you're going to be fixing next. So we can tell you that there are some interesting fixes you need to do. So 5089 in the UK, and you can see. So these are things that are ending up in the wrong place. And for some of them, it's fine because the round trip times are just okay. They're still within the SLA. But if you look at the bottom, there's Rostelecom in Russia, which traffic is ending up in Tokyo. And as a result of it, the round trip time is 200 milliseconds because it goes the long way around. That's not good. So that's what you want to fix. And you can look at this as a whole bunch of manual labor, like engineers looking at screens. But the reality of this is that there's not nearly enough engineers on the planet to go and fix this stuff. And you need to be able to start automating this stuff. And if you want to do like some of the people are starting to do, like building ML/AI models for network performance and network optimization, one of the absolute key things you need for that is enormous data sets. You need an ML/AI platform, needs enormous amounts of input before it starts to make sense. So you need to have a continuous data feed. And if you're just doing this based on flow analysis, so looking at the traffic that was actually on your network, certainly in an early stage like 6Connect, that doesn't tell you anything, because if there's no traffic, you don't know how optimized you are. And if you have traffic, you really already should have optimized your network. So you're in this catch-22 where you want to optimize without actually seeing traffic. So normal tools will only tell you what already happened, and if nothing happened, then good luck. So conclusions about Anycast. Anycast is a little bit like a Formula One car, because if you get the settings exactly right, it is the fastest and best thing for content delivery anywhere on the planet. But if you don't get it exactly right, then things get mediocre really, really, really quickly. And the biggest problem is that the environment is the defining factor. It's not your car, it's not your engineering, it's how you have your engineering respond to what's happening around you. And certainly for stuff like Anycast, you can't just rely on the standard set of tools that you have for optimizing traffic delivery in a unicast setting. You need specialist tools. And that's it for me. Any questions, comments?
We have one question, so I will read it. POP is point of presence.
Yes.
Okay, that's the question.
Okay, well.
Is there any other questions? Okay, we have one.
Oh, yeah.
Hey, Sander Steffann, previous speaker. Roughly how many, because you're testing from the clients,
yeah.
like you said, if you look at your existing traffic, you don't know how much you missed because you never saw it. But how many client endpoints do you currently have that are doing all these tests in rough number?
Rough number. So the rough number is we're doing these measurements from a pool of roughly 250 million endpoints. And those are end user devices, could be like smart TVs, game consoles.
250 million.
250 million, yes. So, I mean, compared to the scale, the rest of the internet, it is a big enough number, even if you take a subset of it, that with statistical analysis, it gives you a very decent level of comfort of what I'm seeing, what's actually happening. So in terms of statistical reliability, you're looking at like 99.9%.
Thank you.
Any other question? Thank you, Remko.
Okay, should we start? Our next presenter.
So don't.
Goran Slavic with 9 things you should know about SD-WAN, but nobody told you.
Hello, everybody. I think we still have 2 minutes, so I'll wait.
Okay, I think that now we have all the audience in the room.
So good day. My name is Goran Slavic. I'm from NCR Serbia, and we will talk a little bit about rather newish technology, still evolving one, called SD-WAN. First of all, there are 9 things that we should know about SD-WAN and things that need to be emphasized about SD-WAN. So what is the SD-WAN? SD-WAN as an evolving technology, SD-WAN as additional layer in our mostly enterprise network, and SD-WAN edge, particular edge installation considerations, underlying troubleshooting that is going on within the SD-WAN, and of course, some of the things that may present a problem, meaning masking on the underlay problems that we have here, underlay troubleshooting in the overlay, SD-WAN operations and maintenance, and of course, SD-WAN as an evolution technology towards SASE. SD-WAN, as I already said, is an evolving technology, rather new one. It's a replacement for the dedicated leased links between enterprise sites in the enterprise network. It is originally meant to substitute MDS, but it can work in unison with it. It's essentially a way to connect sites using secure VPN tunnels. And of course, it allows enterprise to connect remote locations with a high availability to some DCN or hub locations. That's a theory. We're going to see that that doesn't work really like that. And it makes connectivity much cheaper than the standard implementation of the high availability networks. And because it's cheaper, it is literally loved by any kind of management. What is SD-WAN as a definition is the software-defined wide area network. It allows enterprise VLAN to use network tunnels or VPN tunnels over public internet. And the overlay in such a location is a customer visible WAN network on top of the internet infrastructure, while with the underlay we are defining physical connections that actually route the traffic between the sites. Of course, we have standard deployments for SD-WAN. We can connect all the edges between themselves with VPN tunnels, or we can have some sort of hub sites that are connected by the edges. Of course, there is a combination of these things where we would have full mesh of hubs that are geographically located hubs. And at the same time, all these hubs are in some local area connecting edges that are connected on the locally to the local or regional hub. Of course, we have a rather unique way of connecting sites, and that is SD-WAN specific way of connecting sites. That is to connect the edge through the 3 SD-WAN gateways that are in the vendor or provider network of the SD-WAN, while those gateways, of course, function between themselves and they copy between themselves the traffic and are rearranging flows. So for example, if VPN tunnel towards one of the gateways has packet loss, that can be substituted with write packets that came to another gateway. So edge has multiple tunnels towards multiple gateways, and in gateways essentially a device that serves as a VPN concentrator for the particular edge. And the gateways, of course, communicate between themselves over the vendor or SD-WAN provider network. Rather unique feature in the SD-WAN networks is the orchestrator. In some implementations, that's called a dashboard. Orchestrator is essentially control plane concentrator of the SD-WAN. And in the orchestrator, we essentially have all the configurations, control, and management functions of the SD-WAN. On the other side of that communication is the edge that sends all the logs, all the traffic information, all the performance information to the orchestrator. And that way, orchestrator can You can know what is going on a site, even if the site gets suddenly disconnected, right up to the last keep alive bucket that will hold the information needed for you to troubleshoot something, even if it went offline. Essentially, why SD-WAN to oppose to a standard deployment of the MPLS? MPLS is rather expensive, it's rather complex. You are usually tied to a single telecom operator, and that operator might not have MPLS ability to anywhere globally. And of course, there are lead times in deployment of the MPLS to a particular location. So why SD-WAN has another abilities, it is cost optimized, meaning you're just buying an internet link and all the high availability things are integrated within it using VPN tunnels. It's flexible, it's rather agile, meaning you can simply go from one location to another location, buy internet there, and the same device will function on that new location much same way. It has better visibility in control because you're doing everything on the orchestrator, it's centralized. And of course, it's built for cloud, meaning that gateways and simple hubs are usually co-located with the large SaaS or internet infrastructure as a service providers, meaning you can essentially put things right next to, in a rack next to it, meaning that you will have high availability of those services, like a software as a service or infrastructure as a service. These are just, you know, sort of marketing things that SD-WAN is sold with, 45% reduced application latency, reduced times to implement policy and all the configuration changes that you need. And it's much more efficient in the WAN management and other benefits. But what needs to be said is a second big point, is that SD-WAN is a rather new and a very evolving technology, meaning we don't have a single implementation of SD-WAN. There is no, as you can see from the market share, there is no dominant provider of the SD-WAN. Yes, Cisco is the first, but it only has 25%. The rest of the very successful solutions like VMware's VeloCloud or Silver Peak, that's done by multiple vendors, are also very competitive. They have very large user base, and sort of a race is still on. Who is going to be the one that will provide most of the SD-WAN locations and most of the SD-WAN clients? Of course, vendors raced to the market a couple of years ago when SD-WAN started being implemented. So some of the solutions in those times, let's say 5 years ago, were about semi-finished. We're talking beta and alpha versions, definitely not even release candidates. So early deployments faced a lot of troubleshooting and a lot of features were still in production. Some things were missing. Multicast, IPv6, those things were simply not implemented in order to reach the market as far as they can. Also, there is no one specific implementation of SD-WAN. What you need to understand, if you're deploying SD-WAN, all those things are vendor-specific. Protocols that are used are highly vendor-specific or even regarded as a trade secret. So a lot of things is happening under the hood that you simply don't have reachability to. As a logical solution of this vendor specificity, you have lack of training, you have a broader lack of documentation, meaning you are tied to a provider and what they provide as documentation and training. Also, because it's a evolving technology, best practices are still in development. We don't know what is the best practice for some of things. We are finding out as we are deploying SD-WAN networks. Edge installation, meaning replacement of your legacy structure on a single site with the SD-WAN edge, also has its problems. The popular, euphemism that is used, zero-touch provisioning. We just put a box, we power it on, blue cable goes to the blue jack, yellow cable goes to the yellow jack. It pulls the configuration from the cloud or from the dashboard, and everything works. My whole department in NCR wouldn't exist if that was the case, because I work in a build department that actually deploys new sites. So there is a lot of troubleshooting that needs to be done on ISP links. ISP can sometimes firewall certain communication, certain two-way communication that is needed for the site deployment or generally for working of the SD-WAN edge. There is, of course, carrier-grade NAT, regular NAT that can ruin some of those connectivities. And you need to have a serious conversation. Do you need some untrained or some trained personnel on the site to deploy something like this? Also, you need to have a tight consideration with and coordination with customer and with network specialists of the customer in order to make sure that they redirect traffic that was going from the regular structure, from their VPN tunnels or whatever they were deploying at the site, to redirect them to the SD-WAN infrastructure. So that also means that you need to have a coordination with the network design team that probably needs to redesign or temporarily put some, I don't know, static routes or something in order for the part of the network that is still not migrated to the SD-WAN to have the ability to communicate with the SD-WAN deployed part of the network. If you are deploying 400 sites around the world, you definitely cannot deploy them all at once. So there is going to be some sort of a transitional time when from one infrastructure you will have to go to the different infrastructure. Underlay troubleshooting is also very important because a lot of things are happening behind the scenes. A lot of things is happening beyond it. And as you can see, customer only sees this one network that you're providing to them. But underneath it, you have a lot of things, those edge devices, those, for example, different internet providers that are providing internet on one location, then on another location. And SD-WAN uplinks are not MPLS, which means they have a rather weak, or they are not with a high SLA. And this has a logical problem that those things can fail and you're not really protected by the ISP with, you know, high availability or something like that. They are regular internet links like you have at home. So internet access is without SLA or with very weak SLA. So customer will only see the service, while under all that, you need to have a lot of things to worry about. Also, one of the problems is what is called masking of the underlay problem. As you can see on the graph, you have one MPLS link and you have sort of a wireless link that has a high packet loss. It has a lot of problems. So link steering, that is the best feature of the SD-WAN that allows you to steer traffic to the better link, to the link that has less problems or doesn't have problems at all, is actually has a sort of a dark side, because you actually from the bottom, from the top, you see what customer sees, and that's no latency, no packet drops, no jitter, while in the underlay you have a complete chaos. MPLS link failed, everything is going to that weak link. That weak link is compensated by the features of the SD-WAN, duplication of packets, buffering of packets in order to iron out the jitter, then some sort of latency issues, also forward error correction, but essentially you have a chaos in the underlay, but you know, customer doesn't see anything. And while at the moment the customer starts complaining, everything has gone to a place you don't want your network to be. Overlay troubleshooting is what's essentially what customer sees, that is visible to the customer. But customer, again, will only see the service. And SD-WAN is not a classical WAN network. SD-WAN essentially holds prefixes of the individual locations that are connecting to the edge, and edge devices announce them to the SD-WAN. That sort of brings in an additional troubleshooting challenge, because you need to troubleshoot things that you might not, as a senior network engineer, be forced to, troubleshoot until now. It's more like you're troubleshooting BGP in some internet exchange point or something like that. So careful routing procedures need to be implemented to prevent routing loops between those multiple links that are going to the internet. Some of the things are compensated within the SD-WAN, but you still need to be careful with other redirections at your site. SD-WAN operation is maintenance is one of the biggest challenges, because it combines everything I said previous into one organizational thing that needs to be handled either by organization or that somebody who is trained and also proficient in use of this brand new technology. So transition needs to be handled very carefully. You need to have defined ISP communication and troubleshooting towards the ISP. You need SD-WAN troubleshooting as a main thing, then some sort of LAN troubleshooting. So is the problem on the SD-WAN or is the problem on the LAN side? Also, you need to monitor now additional layer. As I said, you have a LAN layer, you have SD-WAN layer, you have this internet WAN layer, or you have some ISP operation that needs to be handled with, communicated with, procedures need to be built for something like this. And of course, you will need field work at location. Zero-touch provisioning is a nice marketing sort of phrase, but you do need people at the location proficient with network things in order to correct certain problems that might arise. Some of these things can be kept in-house, while some of the things might need to be outsourced. So in essence, operation and maintenance can be handled by somebody who is a managed services provider, MSP. They can extend your team's skill set and technical expertise. They can share implementation and deployment best practices. And of course, they can provide insight and experience because they handle these networks, they deploy these networks, and they have lead access to main technology players in the SD-WAN world. It can augment the service, and they can augment your management capabilities. But what also needs to be said, MSP is not a magical solution. MSP is limited by what you have deployed in your network. So your network architect needs to bring out the knowledge about your network. Where are the servers? Where are the important parts? Why are certain parts important or more important than some other? So it's a two-way street. You cannot just say we're going to outsource this and that's it. There needs to be a lot of communication with existing staff in the enterprise network in order for the SD-WAN deployment and maintenance and operations to be done properly. Also, in the 9th part, or the final point, is that we have SD-WAN involving to the SCSE or SASE, and that is a combination of the SD-WAN and the cloud security deployments and cloud security features and services. Essentially, SASE is a secure access service edge. SASE is essentially what I just said, convergence of the WAN and network secured services into a single unified cloud native service as a delivery model. New package of technologies will often include SD-WAN plus some sort of security features, for example, firewall as a service in the cloud as its core component. Delivery is primary as a service, meaning it's a cloud-based solution. Upon identity of the entity, real-time contexts, policies, and so on, It simplifies network infrastructure by merging networking and security services into one unified cloud infrastructure. And some of the conclusions. So SD-WAN represents a highly evolving technology, not to say new. It's 6 years have passed, so it's not new, but it is still evolving in its implementations. Only vendor-specific solutions are unfortunately only solutions available. New SD-WAN implementation, as mentioned, requires careful planning and execution. That means clear design and strategy for the new SD-WAN network, comprehensive redesign of existing infrastructure in order for the transitional period and later deployment to be done correctly. And of course, detailed migration plan to transform the enterprise network to the SD-WAN, and define processes for ongoing troubleshooting, monitoring, maintenance of the new SD-WAN network. Also, there is a need for either outsource or intensive and comprehensive training of the existing staff to handle SD-WAN implementation, monitoring, and operation. Managed services provider, as I already mentioned, is a nice thing to have, but it's not a universal solution for all SD-WAN issues. There needs to be a two-way communications between the client and the SD-WAN or managed services provider in order for that to function properly. Also, you need to watch out for regulatory and legal concerns that need to be addressed when implementing cloud-based solutions like SASE. Where is actual data flowing? Where is actual data going? In order not to violate some of the regulatory policies regarding, for example, medical data or confidential data. And despite industry hype and marketing messages, there are no magical solutions for working and SD-WAN implementation. That would be okay for me. So, are there any questions?
Thank you, Goran. Do you have any questions?
Okay, microphone ungated. Jan-George 6 Connect.
Of course.
I didn't see any specific mention of IPv4, to be honest, but you mentioned some particular technologies that works only on IPv4. So I presume you talked about how it works on IPv4. How would this work on IPv6, and why you didn't mention it?
Because multicast has been recently introduced in most of the SD-WAN networks, and we are still waiting for example, good deployment in some of the SD-WAN solutions for the IPv6. Officially, there is one, but I'm still waiting to see that in production. So I don't want to talk about anything I didn't test it thoroughly.
You mentioned that there are...
Your name, please?
My name is Vejko Kosh. I'm here independently. You mentioned that there are issues with deteriorating links with SD-WAN. Are you aware of any emerging solutions to the problem, or is anybody from the community aware of any?
Deteriorating links that are used in the underlay. What I wanted to say is that the SD-WAN network, even though it's not using it's over the overlay, meaning it uses its own tunnels and its own things, needs to be very carefully monitored with regards to certain degradation of the links. It simply can't be left on its own and said, we don't care what happens in the underlay. On those physical links, our traffic is flowing normally, and that's all we need to know. You need to monitor those things very carefully for degradation, even though those superior features of the SD-WAN are ironing out most of the problems that we have in the SD-WAN.
Yeah, so I'm relaying a question from the chat from Sox Nenand. I'm sorry, I'm butchering the name. Nenand. He's asking, since SD-WAN is using cryptology, Does it need specific hardware on endpoints, or it can be installed as software on a standard hardware?
It can be installed on as the virtual device. For example, VeloCloud has a virtual machine that you can install in most of the deployments, but it does have physical devices. All of them have both the virtual component or a virtual implementation of the edge and the hardware component. Usually that hardware component comes in different sizes regarding how much traffic it's going to use or how much traffic is expected to pass through it.
He also has another question. Does it support multicast traffic?
It does, but very recently, not longer than 1 year. Most of the implementations got the multicast.
And the final one, it's a bit long. Since SD-WAN is an additional layer, it introduced additional overheads. Since MTU of the internet link is still typical 1500, effective MTU of SD-WAN link is less than standard MTU. It can have significant impact to different services like VPN used by customer, and not all services have good path MTU discovery implementation. How this is handled by SD-WAN implementations?
It's usually handled because those packets are not flowing, let's say, normally. They are packed into the vendor-specific packets that are, so the whole protocol is different. They are fragmentized and then they are reassembled on the other side from different even, not only packets, but different even flows that are defined within the SD-WAN solution. We didn't have problems that were mentioned there, but most of these things, as I said, are very vendor specific. So I don't know how actually they do it. I just know that it works. Because as I said, it's a very vendor specific thing, and we are a provider of such services, but I don't know all the details. They're most likely classified as trade secrets. How do they do it actually?
Yeah. And those were all the questions. I'm going to attempt to read the name now. Nenad Krajinovic. I'm hoping I pronounced that right.
Yes.
Thanks.
Okay, thank you.
Heather? Thank you.
Next, we have Vesna Manojlovic from RIPE NCC with the Community Projects Fund Success Stories.
Dobar dan, Ljubljana. Hi, I'm so happy to be here in a place that used to be part of the country where I was born, and part of my heart is still belonging to Ljubljana. I'm Vesna. The original title of this talk was Community Projects Fund, Success Stories, and it is still the title, but I uploaded different slides. So can the tech team help me use a different slide deck on this, please? In the meantime, I can amuse you with the stories from the previous times when we were in Ljubljana and we had a RIPE meeting here. How do I unshare this? Let's do it again. Tech team, help. This is what happens when you change your presentation in the last moment. Okay, I'll rely on humans instead and just start talking about the Community Projects Fund. Who of you has heard about the Community Projects Fund? Yep, there is a few of you. So this is one of the favorite parts of RIPE NCC's work for me. It is, in the way I see it, it's the mutual aid and solidarity. It is community helping each other. And the RIPE NCC is only coordinating this help to go from those who have contributed more to those who need some additional funding. We started with Community Projects Fund 5 years ago. And there has been a lot of successful projects that received this money over the years, and you can read about the reports that they produced on the RIPE Labs. The call this time, if I only have the elevator pitch, is we need more projects from the SCE region to apply for funding, and we also need people to volunteer for the nomination committee. And so that's why I added these other 4 letters, which is justice, equity, diversity, and inclusion. So I first want to highlight 2 projects from this region. On the top picture, you can see Internet Atlas, and you can also see some familiar faces. Desiree was presenting at this meeting. She's very active in the RIPE community and the SCE community, and this project received funding in 2017. Their goal was to educate users on the usage of the internet and how the internet infrastructure works. On the other picture, you see Petros and other people from university in Greece. And their project Artemis is about monitoring and monitoring network performance and measurements based on RIPE Atlas data. They received funding twice, and they have published a lot of articles, a lot of reports on the RIPE Labs. So who does which work? The RIPE NCC is doing all the admin and logistics and legal support for this whole process. We earmark €250,000 every year for the projects for the good of the internet. The money comes from the members of the RIPE NCC, so thank you. And since RIPE NCC is a not-for-profit organization, we then share this with the community. So we give it back to the community in this process that has been designed with the community, and it's actually safeguarded by the community because nomination committee also comes from outside of the RIPE NCC. So we really only do the administrative part. And the most important part is the rest of you, because it is your projects that are already changing the world, changing the way how the internet works, and it is your work that is being then rewarded by this financial support. So please spread the word or apply yourself. We have a timeline. Every year is more or less the same. I don't have the precise dates, but this year we also have the election for the nomination or selection committee. It's not an election, it's nomination. So you can nominate yourself or somebody else that you trust. And then a bit later, around the RIPE meeting, we will have an open call for the actual funding of the projects. And here you can see the beautiful faces, and underneath in very small letters there are names, and it's your next quiz to actually connect the names with the faces. I will leave that as the exercise to the participants. What you cannot see here is faces from the Balkans or from the Southeast Europe. So this is a special opportunity now for me to invite you to be active and to nominate yourself for this selection committee. There isn't a lot of work involved, so you will have to read through these proposals of the projects between let's say May and July, and then you will have to agree with the other committee members. Normally there are 5 people, and they stay between 1 and 3 years. And then there is some overlap and continuity, and some of them are actually from the executive board, so they have been voted in. Some of my favorite projects, and you can see their success stories, as I said, on the RIPE Labs. I'm very fond of it, so I always promote it too. And so every year, yeah, there is something interesting and nice going on. The main point for me in this is that by publishing about their work on RIPE Labs, there is accountability and there is transparency of where did that money go and what has been done with that. But also one of our criteria is that these projects have to use open data and have to produce free software so that it can be reused and modified, and that people can learn from their example, both like in theory and in the results that they have produced. So how do we move from good to great? Well, we can move from the criteria that we are using, like accountability, transparency, ethics, towards justice and towards different criteria. What does that practically mean? How does that translate to the actual criteria that are tangible, that we can implement in what we are doing? Well, we already name it. We say, well, we fund the projects for the good of the internet, but the good is kind of the ethical question, like what is good? And so we choose some criteria. For example, projects have to be community driven, they have to be non-commercial, and they have to contribute to the open and resilient and stable or secure internet. So even there, in that criteria, there has to be some balancing between, like, how do we choose that? Or should they be more focused on sustainability or on the growth? And so on. So we always have to make these value judgments, and they can be based on ethics, but they can also be based on combating or redoing the injustices that have somehow crept into the design of the internet over the years. So we have started with all this open, decentralized, end-to-end, but now what we have is commercialization, splinternet, corporations are taking over, there's a lot of consolidation, and that is not leading towards the justice for the users. And so our focus on in 2022 is to bring more equity concerning where these projects are, because internet is global. And to start with, we were focusing on our service region, but we have also funded the projects from Japan and from Canada. And we are really looking forward now to more projects from, first of all, Southeastern Europe, but also from the Global South and from Middle East. We also want to make to receive more inclusive applications. We have made the process more inclusive, and now we are looking for the content to be more inclusive. And as I said, we are looking for more diverse participants in the selection committee. And since I'm speaking to you, that means please apply if you are from Southeastern Europe region. There's more. There's more. So funding is a great thing, but it does come across as a hierarchical relationship, as one directional kind of helping approach. And the value that these projects that are applying brings to fighting like the systemic problems, to solving systemic problems, are larger than the monetary value that they receive as funding. So we are all contributing to each other in the ways that we can. And so I am asking all of us to work together and to find new ways to work in solidarity rather than me helping you receiving. We are all in this together. Thank you.
Thank you. Questions?
It's me again, Jan George from Six Connect. Did I understand you correctly that this is limited to software projects with some source code outcome?
I did mention source code, but it is not necessarily software projects. The outcome can also be documentation for the education of users. It can be, for example, measurement tools that are visualization tools. So the software is a secondary outcome, but the actual usage of the tool is the result, and so on.
So what's your feeling? Would the Keep Ukraine Connected project fit into this, or maybe not?
I am not part of the nomination committee, so I would have to consider. The feeling is, yes, I would love it personally, but maybe you need to limit your application to a certain part of the project rather than the whole project.
Thank you.
Yeah, let's explore it together.
Okay. Thank you very much.
Thank you.
Next and the last, Hisham will do the closing.
I could use some help with the slides here, but as we're doing this, I do have a couple slides for the closing, but as I am being given the permissions to do what I need to do to put up the slides, I would like to thank the co-hosts, and we do have some gifts for them. So if I can ask Jan George on behalf of CNOG and Tommy on behalf of Arnes to please come on stage. Yeah. Thank you very much. Thank you very much. You guys have been wonderful hosts, and thank you for making everything very easy for us here. Much appreciated. You guys want to say a couple words? Please, please.
No, I just wanted to say you've been very nice guests too.
Yeah. Okay. Great. Can you help me with the slides here? And yes, thank you, Mano, for that. So yes, the closing slides. We have a few statistics for you to share and numbers. So looking at the SEE 10 meeting that is coming to a conclusion now, we had just shy of 300 people registered for this event, both online and in person.
The on-site were 143 participants, and for the first day we ended up with 123 unique participants in the grand hall here, and 17 in the white hall. So we can see that in this hybrid event that we ended up with like a 50-50 mix, which is a very good number, I would say, in terms of participation. For the second day, we still went strong with online participation with 105 unique participants showing. So it did show that both days were interesting for online participants, not just for people on site. And I do think that's something very much worth noting here. If we look at participation by country, and I won't read through a whole list, but you can see your flag and you can see the number of participants. This includes both on-site and online. And you can see a nice mixture of countries from the region here participating at the events. I did mention and thank the hosts. It couldn't be done without them and the great work that they've done there. We also had great connectivity sponsor from Telekom Slovenia and a gold sponsorship from ISOC. Thank you all for your contributions there. And thank you all that attended for making this meeting such a success. There's also a group of people that have been working for some time on making this meeting a success, which is the PC committee. And I would like to invite my fellow PC members to the stage so that we can also show them some token of our appreciation as well. So yes, the PC members, please another round of applause for them. They did a great job and a great meeting. Yeah. Okay. Thank you all. Thank you all. And for those that are not here, we also got them gifts, but we'll send it to them at their homes. So, yes, did you enjoy the meeting? This is a question that we always ask people after the event. There is a very easy QR code that you can scan and get a survey. Please let us know your thoughts. Let us know what went right, what went wrong, what did you like? Did you like the history panel? Do you want to see more of those? Because that's a question that the PC was talking about during lunch today. Did you want to hear more topics that you didn't? And if so, what are they so that we can take them into account? There will be a prize draw that will be done. So please, I see a lot of people already scanning the QR code. If you haven't, I will leave it there for 10 more seconds, and then I will move on. And yes, let's stay connected. There is a SEE. Oh, you need it back? Okay. I said 10 seconds. So I can continue talking about the next slide while you guys are scanning this. And let's say connected, there is an SEE mailing list, and we would love to continue these dialogues. It's great that we meet once a year and discuss in person. I mean, hopefully from now on, it's once a year. Last time we met in person was Bosnia 3 years ago. But continuing the dialogue is very important. And this is something that we figured out also very, very much during the COVID times. Again, I mentioned in the opening slides that for the 2020, the PC made the decision of not to hold an online event because we don't have the culture of doing online activities. by 2021, we did an SEE event online that I think went quite well and was quite useful for us to continue to stay connected. And for us to continue to stay connected, I think needs to be the theme moving forward. And the mailing list could be a very good way for us to do so, even with meetings being face-to-face again. And yes, there is a link to the SEE mailing list. Please join and subscribe. You also may have heard me say in the opening notes that we are looking for hosts for SEE 11. If you are interested in hosting, please let us know by the 9th of May. And there's also a URL here that you can click on and we will know where we are going next. Yeah, a couple final notes here, wrapping up the SEE 10. The SEE 10. This meeting was the first meeting that we actually had since the RIPE 79 meeting in October 2019. It's the first hybrid event that we've done. And we do appreciate your support in us experimenting and trying new formats, whether if it's with the queuing, with Mythico. We have a lot of lessons learned. We got a lot of feedback from the PC members during the call. We got from participants. And I do know that my colleagues back in the support room have also figured out a lot of stuff that we will take into the RIPE meeting as well. So we do appreciate your understanding if anything didn't work exactly as you expected, but I do think overall the meeting went quite well, and I'm very happy with the results. And yes, and for the online participants, we do have a nice small reception in the garden room. So after we're done here in a second, well, please join us all there for that. I would like to also mention something else here about, it was great to meet everyone and for us to, we had all the different badges about, do we want to shake hands? Do we want to hug? Are we up to, just nods and stuff? And it's important that we are also aware of while the restrictions for COVID have been relaxed, it doesn't mean that it has completely disappeared, right? And what we would like to ask the participants is, if you test positive for COVID-19 over the next week or so, to please let us know. We will keep your data anonymous. We will not share it with anybody, but we will let other participants know that they might have got in contact with somebody that had COVID. I think that is something that, as our social responsibility towards the others, it would be a nice thing for us to be able to do. And we will keep your data private. We will delete it within a week afterwards, so we will not keep a record of this. However, sharing this information and sharing this information is not obligatory. However, it does minimize the spreads and the risk for everyone else. So I would appreciate if you do let the meeting organizers know if that is the case. Last but not least, RIPE 84 coming up within a month in Berlin. I'd love to see you all there. And if you cannot make it in person, well, we figured out how to do hybrid here. So we would love to see you in hybrid as well. Thank you all. And with that, this meeting is done.